Yeah, what I thought I would do is, I can start a little bit in the background of computing and say a little bit about some of the computers that I did develop for seismic processing.
Sure.
And that shouldn't take too long, but I thought I'd go ahead and fill that in because that's a lot of the initial computer design work that I did for working for TI and their seismic operations.
Yeah, I do know TI had an extensive background. In fact, I've read that that's kind of how TI got started, wasn't it?
That's right. Originally it was GSI, Geophysical Systems Incorporated, and they spun TI off as they began to do a lot of electronics, and they figured the electronics would be a business in itself and wasn't directly involved in the seismic business. So they anyway, I went to work. I went to school at the University of Texas in Austin and spent 10 years getting my bachelor's, master's, and PhD. Then during that period of time, I was fortunate, as a starving student, of course, tuition when I started was $15, and it went up to 25 and then to 50 during that 10-year period. And I was trying to get them, they call it a registration fee, and so I testified before the legislature to try to get them not to charge tuition, because the Constitution says the University of Texas will provide a university of the first class for the citizens of Texas. And the original interpretation was that means no tuition. Mm-hmm. And then when Rice got sued because they didn't allow black students, they suddenly decided, you can change some of these things that are in the charter. Right. And so they went ahead and applied, and of course the legislature thought, this is great, it'll save us a lot of money. Right. And they started tuition at $100 and $300 and $700 and $3,000 an hour, whatever it is. It's not cheap, but they have like 50% of the students are on some type of scholarship. But that's a whole different picture. Anyway, when I started school, during my sophomore year, I was looking for a job, and the job I thought was open had just gotten filled, and it was at the Pickle Center, which used to be the Balcones Research Center, and the guy there said, are you interested in analog computers? And I said, sounds good. So talk to so-and-so. Dr. Ripperger was in the engineering mechanics department, was looking for a student to repair an old World War II analog computer. And so I told him, I used to like to fix TVs and all that sort of stuff. He says, well, okay, we'll hire you. And so I learned more than about 4 courses worth of material repairing and operating an analog computer as a sophomore before I even took my first electronics course.
And about what year was this?
This was in, I started in 54, 55. This was 56, January 56. And I worked there until I had to go to ROTC summer camp, in which time I left. And then when I came back, the job wasn't there anymore. So then within a semester, the next January, I got hired by the research lab, which is now the Applied Research Lab. It used to be the Defense Research Lab. And it was right on campus, right by the law school. And so I worked there until I finished my PhD. And initially I took a heavy course load with a light workload, working like less than half time. And then I decided, boy, that's a lot of work to take all those courses in graduate school. So I dropped to 1 course per semester and finished up my PhD with full-time job there, which paid well. So I was able to buy a new car and do all kinds of stuff. Where the car I was driving I bought for $60, a old 46 Plymouth, which had one fender sewed together with baling wire, and the battery didn't charge, the brake fluid leaked out, and I adjusted the regulator, replaced the wheel cylinder, and drove the car until I started working full-time and could buy myself a brand new, I bought a VW. Anyway, working there, I learned an awful lot working on the analog computers. Then at the Applied Research Lab, I designed electronic equipment, and I was interested in computers. They got a digital computer at the Experimental Science Building, a IBM 650. It had a drum memory, rotating drum, so it did one instruction every rotation of the drum, really fast. And so I immediately took the first programming course to figure out, hey, what's the difference between digital computers and analog computers? And so then I took all the courses that they offered. In general, it was the first time they offered electronics course. I took a solid state circuits course. First time they taught a logic course, I took it. The first time they taught the algorithmic mathematics type of course, I took all those courses, and that set me interested more in computers. And when I got my bachelor's, TI came and wanted to hire me. I said, no, I'm going to work on my master's. That's great. We'll talk to you when you get your master's. I got my master's. They came back and said, I'm going to finish my doctorate. Fine, we'll talk to you again. So when I finished my doctorate, this is the Houston manager. Decided, sure, I'll go to work in Houston. And I walked in and they said, would you like to work on circuits or systems? I said, oh, I've done enough circuits. That's what I would do for my research. My work at ARL was doing instrumentation, building special analog filters for acoustic measurements out on the lake. And I had to learn to scuba dive so I could dive down and help them. And so I said, I'll work on systems. He says, oh, okay, we need somebody to speed up our new seismic computer, the 827. And that computer was built really fast. They had a professor, Marty Graham from Rice, that was advising them. And so they had the biggest core memory you could get at that time was 1,000 words. And so they had this 1,000 word, and then they had a loop memory that stored the information because the drums weren't available yet, disks weren't available yet. And so they had all that and were processing the land seismic data. You have 24 channels of data that came in, and TI or GSI kind of pioneered seismic processing. You know, a lot of people said, oh, it won't work, you can't get the information. Well, they had a big analog drum, which they took little analog filters and mixed and matched it and could identify the strata which looked like it might have oil. In other words, oil only stays in the ground if you have a trap. And so if you can look and see the limestone reflections and it looks like it might be a trap, then that's where you want to drill. And if you're lucky, then, hey, it really has oil in it, not coal. So anyway, they gave me all the digital books that they had. It's about 6 books in those days. In 1964, there was not a lot of material on computing, but there's some. And so they gave me all those books and said, see if you can figure out how to speed this thing up, because we're just getting ready to have marine data. Now for the marine data, this is off the North Slope. You know, they have the ships and they have this mile-long line of geophones that they pull behind the ship, and then every 20 seconds, 10 to 20 seconds, they set off a blast in the water, and it goes through, and they pick up the information and record it. But if instead of having that amount of information, and then you have to pick the line up and move it, and then get another set of information, they're just doing this bang, 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 and so I sat there and I worked on that. I'd started in, I guess, around the 1st of March, and so in June, the associate organization at TI was having a trip to Europe. And I thought, oh boy, I'll sign up for that because I'd like to take Reba to see my grandmother who lived in Switzerland. My dad was from Switzerland. He was a petroleum geologist out in San Angelo. And so I started working on what I might be able to do, and I figured out a few things. I sketched them on a piece of paper and gave it to my boss and went off to Switzerland for, I think it was 10 days. And when I got back, they wouldn't even before I even could get to my desk, they stopped me and said, this looks good. We want you to build it and deliver it in 6 months. And so we went to full gear. Now we were using transistors, the fastest transistors TI could make, and putting them on little circuit boards, and have these racks of, like 1,200 boards in it, and they had if the connection on the backplane was more than 6 inches, you had to use coax, miniature coax, and so they had I think 5 miles of miniature coax on this whole thing with 4 racks of things, and so I designed a F box to go with it. Well, first I designed the initial unit to make the A, and followed it with the A1 right after that. But we worked, the last part of it. As soon as we got the work going, we were working like 7 days a week, 24 hours a day. And what I would do is I would come in at 7 in the morning to talk to the night crew and stay until like 7 or 8 o'clock at night to give them whatever directions. Then at night they would do whatever rewiring needed to be done. And so we were working like that for nearly 3 months. But we got the whole thing working and delivered the system by the end of December, and then immediately started on an upgrade to it because new technology was coming out really quick. And so we followed it with a unit that has a drum, external memory, 4,000 words instead of 1,000. And
I found this on the web.
Oh, shut up. Sorry. Turn off my phone for sure. Anyway, we built this unit with the F-box and the rotating drum and extra memory, and ended up making a Harvard architecture. That says that the instructions come out of one memory and the data comes out of another memory. And the memory was built as 2 words wide, so that you could have, if you're trying to do, you're trying to do a bunch of digital filtering, so that you're doing you have to do the sum of a bunch of products, and so you have to have something that does a lot of multiplying adds real fast. And so they ended up building these, and they had them in Calgary, in the Netherlands, in the Humble Oil had one in Dallas, Texaco put one in Houston, and so a few years later I was taking my wife and children to England, and we went to the
Here's
British
what I found.
Science Museum. And the Science Museum had a picture of my computer. I was looking at that. It was in the geology section. And it had a sign on it. And the sign said, "The fastest commercial computer in the world," which made me feel pretty good. Unfortunately, I didn't take a picture with a camera, which is, would make sure that people believe that I really did see that. But anyway, that was my beginning. Now, while all this was going on, the semiconductor department said to the Dallas management, "We want to buy this 24-bit computer that's made by SDS out in California and San Diego to test our test station, that the transistors come out and you have the really good ones and the medium ones and the not too good ones, and then what they call the AWODs, aren't worth a damn." And so they'd like to have something that did that. So the Fred Busey, the manager at TI for that division before he became president and then chairman, said, "Houston makes computers, go down there." And they said, "Oh, that's way too big." And my boss said, "Oh, we can build you one. Tell us what you want." He says, "Well, we want something like SDS makes." So they took me and a group of engineers and put us in an old abandoned dime store building so that we wouldn't be interrupted. And we had to deliver within 12 months. They said 12 months from scratch. So they didn't have an instruction set, didn't know which family of devices we're going to use. We had to do everything. Had to program all the software. And so at that time, the latest integrated circuits were the 73 series. And they were ceramic package with gold leads in a flat pack. And but they worked. They were good, relatively fast. So that's what I used and made. I did a bit slice, 24-bit machine. So I put 3 bits per slice and had a rack of bit slice and a control. And then I took 4 of these quad inverters and soldered all the leads together to make a common clock. So because all 8 boards had to get the same clock signal at the same time, and to make it all come out. And so that worked good. And so that kept the thing. And we would have to hand solder these little flat leads together with a solder gun. Well, sure enough, the semiconductor technology, was taking off like a rocket. So the very next year, the 73 series was totally obsolete. They had the 74 series came out, and they came out in a plastic dip, and those components were just sold them like bags of popcorn. Right. And so that meant that the computer, this nice 24-bit computer with a workstation and a desk, was obsolete. So they said, "Oh, these mini computers out here are what we need, so we want to buy these instead of yours in Houston." And of course my boss said, don't buy one of those, we'll make you one. Right. And so I designed the 860, which is the it's a 16-bit mini computer, and we use the 73 series logic and had a nice little rack mounted, and DEC had theirs computers out, mini computer out, and Data General had a computer out, and Honeywell had a computer out, and GE even made one that they gave anybody that bought a power plant. If you bought a whole power plant, you got a free mini computer. Anyway, we ended up with that machine, and it was, a lot of the people thought that you could make them as inexpensive as you can to be competitive. Well, we got the latest integrated circuit, so we were able to make it and keep the price down. And my boss instructed me on doing design to cost technology, which Ford, when they did their the Mustang was done the first commercial design to cost job. He came from the military, and they had learned to do design to cost on military projects. So he had McNamara went to work for Ford and had them build. When the Edsel failed because it was too big, people wanted a nice sporty car. He had a crash design done to develop the Mustang, and it turned out to be, of course, a super successful program. And so, thinking of that type technology, but the one thing I thought of is you never know who's going to use these machines. So I built a somewhat faster multiply, where other machines quite often didn't even include a multiply. So in business, you don't multiply very often, and why waste? Because it takes a fair amount of extra circuitry to put in a fast multiply in particular. But I went ahead and put in a faster multiply in it. So we ended up with a computer that cost half of what anybody else had and ran twice as fast. And at that point, we wanted to design a new seismic computer, but the military computer group in Dallas that built a lot of military computers, including the flight control computers for the latest fighters, they didn't have anything to do. So they decided to give them the next computer job that my boss and I both wanted to have the opportunity to do. And so my boss, my supervising professor from the University of Texas, had become department chairman at the University of Missouri. And he calls me up and says, "Boy, we really need somebody to teach computer systems up here." And they had stolen all the projects that I wanted. So I said, okay. And so I ended up leaving and going up to Missouri and taught computer engineering for 8 years. After 7, you can take a sabbatical. So at the end of the 8th year, there was kind of a break. I had, I think, a total of over $1 million worth of research contracts, and I ended up with 15 students that finished their PhD under me up there. And I got one of the computers that I designed. We bought one in one of the contracts, and we built a hybrid computer because computers still weren't as fast as what you could do with analog circuits. So I built a computer that had 6,000 op amps. It had 500 4-quadrant multipliers and 500 D to A converters and a TI 980 mini computer, and we could simulate the total power grid. I ran the whole thing at 6 kilohertz, which was 100 times real time. So they could determine whether you were going to have another New England blackout. And so I built that whole system with money from the Electric Power Research Institute. And after 8 years, I decided I'd take my sabbatical. After 7 years, they give you a sabbatical at the university, and I came down, and the people, the supervising staff in Houston said, "Well, we don't need any PhDs down here." So I was on my way back up to Dallas, and I said, "Oh, I'm going to stop and see my old boss. He's at TI." And I stopped in to see him, and he said, I was thinking that I'm going to just scrub the sabbatical and go and just continue at, is what I had in mind. And he said, I would like to build a home computer. And my key designer, who designed the first some of our high performance calculators, like the TI-50 that was designed that could sell at half the price of the Hewlett-Packard 35, and so it sold for $200 where theirs was $400, and but he had gotten cancer and died, and said, I really need somebody. I'll offer you a job right now. You know, whereas the others would, no, well, we'll think about it, we'll check. And when they checked, the supervisor down there, the management in charge of Houston, said, well, we don't need anybody of that level. You know, it's too much money. And so he just said, on the spot. So I went back up to Missouri and prepared to go down and work for a year building a home computer. Well, it takes a while to get it all specified. We had to take 3 passes through the management committee that reviews new programs. And the key thing they wanted says, we don't want you to just go out and build a game. TI's not, that's the wrong image for TI to be in the game business per se. It's okay to have games, but that can't be your number one focus. You got to build something that's more than a game. Sure. So that was our instructions, and so I said, yeah, we'll do that. And I, really looked exciting, and so they, I had my house in Missouri, and I bought a house in Dallas, and then a month later, they said, we're moving all of the consumer products to Lubbock.
And about what year was this, by the way?
This was in '76. Okay. And so that announcement came out in January, I guess, of '77. So
what was the driving factor? Why did they want to move it all to Lubbock?
Well, TI had decided that TI was growing so big and so fast, they didn't want to be like Boeing, where if they had a setback and had to lay off a bunch of staff, it would have a big negative impact on the city. You know, Boeing was a disaster for Seattle when they lost some of the big contracts to McDonnell Douglas. And so the TI top management had this idea. What we'll do is we will have major centers in Houston, because Houston was already there because of the oil business. They had bought a small company there, and the operation down there was there. So they already had that, and said, what we'll do is we'll build plants in Lubbock and Austin and distribute part of it. And then they had to decide what's going to go where. We got to move something. And it looked like a consumer was a growing business, so it'd be great to just send them out to Lubbock and let them grow out there. And so they opened up the plant in Lubbock and moved all the calculators out there, and including the new home computer stuff. And so here I was. I had a house in Missouri. I hadn't sold it yet. I'd bought a house in Dallas, brand new. And then if you're going to go to Lubbock, all these engineers going out there, the house prices are going to do what? Mm-hmm. And so I immediately got on the first plane. They flew a whole group. I had a private plane, a chartered plane, took us all out. And I bought a house that first week, right off the bat. I almost bought outside the loop. There was a real nice house there. They were showing where a school would be built and everything. But we couldn't get the door open because the sand was piled up in front of the door. And the lady that was showing us the house said, "Let me go to the office and get a shovel, and I'll shovel the sand out." I said, "No, don't worry about that."
You didn't want shoveling to be part of your routine, huh?
Why don't we look inside the loop where everybody's got a big, tall wood fence in Lubbock, and that keeps the sand from building up for any one person. And so I went in and found a nice house inside the loop, about a mile inside the loop. And so now I had a house in Lubbock, a house in Dallas, and a house in Missouri. And I managed to sell each of those two. And the Dallas house, the week after closing, I signed a contract to sell. Just right out. I didn't want, to be in the business of trying to rent property for long term and all that kind of stuff. I was more interested in doing the technical stuff.
Sure.
And so then we were out in Lubbock, and then we started on the home computer, and that's where it all came in. Now, the home computer had some challenges that we had to deal with. One of them was the plan design that I had was going to use an 8-bit computer, 8-bit CPU, because memory's still pretty expensive. And it was all 1 bit wide, and so you have to buy 8 memory chips, which was a big chunk of your budget. And so that's what we did in any case. But Houston made the 9900, and they forced us to use it.
The 900 CPU.
CPU, yeah, the 9900. And so, in fact, the executive vice president flew out in his Learjet, picked up my boss and we flew to Houston and had a negotiating session so that we settled on, okay, we'll use the 9900, but we won't pay you any more than we have to pay the second source. Well, the second source was selling them for half the price that TI was, because TI wasn't sure that it was going to be a high volume product. So they hadn't run what they call the design verification, because it, at that time, took enough computer time to run a full design verification. It cost about $100,000, which in today's market is, almost $1 million, probably $800,000 equivalent today. And that's a big chunk to spend, and they figured we aren't going to sell very many of these computers anyway, so big deal, It's only everybody was thinking that the computers were all the interests of computer geeks. The Apple had come out, and the Apple was the computer geeks. North Star had, their 8-bit computer, and the one in, let's see, what's the name of it? In Albuquerque had a little, they used the higher speed 6502. The North Star used a 8080, and
the Z80 processor.
Z80 came right after, because the 8080 came out and didn't even have a parity check. That got fixed pretty quickly, but it was designed by semiconductor people only, not by computer people, because it cost one flip-flop to have parity check. They had everything in there. All they needed to add a flip-flop and a gate, and they had parity check. Right. And they could have done that, but they didn't. But they wouldn't, of course, TI wouldn't let us use an 8-bit computer because they weren't making an 8-bit computer. And so we were...
From the start, they had...
From the start.
16-bit machine?
They had the 16... Well, no. We cut it down from 16 bits to 8 bits. I just had a little register that broke it into two halves, and it read one then the other. And so everything worked. And then immediately the next version, they modified the 9900 with an 8-bit interface built into the computer. So it came out, it was a 90, I forget the exact number, but it was the one that when we came out with the 994A, we were using the one that had I didn't have to put the double registers in to split it. And so we wanted everything 8-bit tokenized, and there's a whole bunch of, errors that people assumed, like the solid-state software modules. We were using P-channel ROMs. P-channel is like less than half the cost of N-channel, but you can make good ROMs with it. So we were using you could take a P-channel ROM and you could build it up to the last mask, and then you could have them all and store away without doing the last mask. And then if somebody wanted a chip, all they had to do is to buy that $1,000 mask. And so for $1,000, any person, even if you're doing software at home, you can spare $1,000 and buy the mask that makes that chip. And the solid-state software then can't be duplicated.
And you're talking about the cartridges, you mean?
Right.
Yeah.
And so we could have, they were thinking that we were doing it in order that only TI could make software. But what we were doing it for is so that everybody could make software.
Sure.
And the press just completely, cat, go. The press, they just didn't want, they had a different vision, and they publicized it as TI hogging all the software. And once you have all of the media going in one direction, you can't change their mind. It's too expensive to go and try to erase all the stuff that it was out there.
Well, did TI management actually view that as a potential, say, side business that would come from the home computer market, where if they were enabling private developers to make the mask ROMs for their software, was that kind of a strategic part of the home computer ecosystem, or? No.
We only made software modules to show people what could be done.
Oh, okay.
As a model. Okay, here's what you can do the same thing. All you got to do is to go buy some of these ROMs and you can make all kinds of software. And so we worked with a number of companies, and so we worked with Control Data, had the Plato system. I don't know if you're familiar with that. Yeah. But the Plato system was very expensive. It's like a $10,000 terminal. Right. And they could run Plato on the home computer. And so we had a deal with them. Milton Bradley could do software and make games, and so we had a deal with them. We worked with, at that time, Reader's Digest was doing some work with CompuServe, and we could use CompuServe so that any home computer could communicate with any other home computer anywhere in the world, as long as you got a telephone.
Yeah, modem. Right.
And a modem. Now, AT&T was not cooperative, so we had to use muffs. They won't let you directly connect to the telephone line. Right. And so, but we got around that by doing muffs, and I think we could run up to 9,600 bits per second was the maximum we could get through the frequency limitations at the telephone. Now, the telephone system is designed specifically to roll off at about 3,000 and at 600. They have a very cheap transformer that has very bad characteristics at low frequencies and high frequencies, which is just perfect to use as a free filter.
Sure.
And so that's the reason why the telephones are so cheap, is because that's what they run through to interface with their lines and not get a bunch of static and not get a bunch of hum.
Right.
And that's so in any case, we had all these deals, and we even had a power company that had agreed that they would supply a home computer to every one of their customers, just as part of their electric connection. If you connected it to electricity with the power company, then you got a home computer. Now, their plan was that they could then sell all kinds of new services using the home computer in more things than just managing the power.
Right.
And so you would have a home computer built into every house that was built for that one power company. And then if they were successful, all the rest of the power companies were going to jump in there also. So, we would have blanketed the whole United States with a, 40% penetration of computers. And that's a lot of computers.
Indeed. Was that deal something that was kind of set up at the start of the home computer line, or was that something that came after?
It was in the middle. And so that was right where we were at. Then came the disaster. And the disaster was the manager that my boss reported to, he and that manager didn't see eye to eye. Well, that manager then got a new job in England as a general manager of TI Limited in England. And his parting gesture was to hire a new person that my boss had to report to. Well, this new person came from DEC, Digital Equipment Corporation, and he had everything going great. It looked like we were going to be able to get up to 1 million computers a month. And then it started to dip. And like all, new products like that always have a peak and then they dip. And they dip to half or maybe a third, and all you got to do is be prepared. I mean, he was there with running 2 shifts on the production line and getting ready. Instead of cutting off the second shift and waiting until the things ramped up, at that point he added a new production line so he could run 2 production lines, 2 shifts, and get up to a full 1 million a month computers out the door. And he got that started, and in order to get the sales, because competition was beginning to come up, he decided we were selling them for $150. The cost was $127. So that's as low as we could go.
Sure.
At least that's what we thought. He dropped the price to $100. Well, guess what? I keep saying Sherman, the Sherman Antitrust Act says you cannot sell in a general market below cost. You're forbidden from doing that. If you sell below cost, the federal government will come in and put you out of business. And sure enough, he was violating the Sherman Antitrust Act. They came down, and what TI did to protect the rest of the company is they said, we will go totally out of the computer business. We're out. Everything's out.
Including mini computers and everything? Or
Yep,
just...
everything. The mini computer operation in Houston had 100 city centers. They could deliver a mini computer to any business within 3 hours. A replacement. If you had a computer down, you could go in and have a replacement while they repaired your computer. in the top 100 cities. I mean, they were, I think, number 3 behind DEC and probably Hewlett Packard, and moving fast towards passing them. And they were shut down overnight. Next week, they were no longer selling any computers. Just like that, bam, just like a guillotine. And that, I don't know, TI can probably start selling computers again if they wanted to. They've finally gotten rid of all of their equipment business. The only thing they've got left is calculators. They've sold off their government products to Raytheon. They sold the geophysical stuff to Schlumberger, and are now concentrating on the Internet of Things requires interface chips, because things don't directly interface with logic chips. So there is a huge market for all these interface chips, and they can't all just be uniform. You have to have a pretty wide variety of different types of special interface chips. And so they're going gangbusters now. The business took a big slump for a while there and then slowly back up, and now they're cranking away. They did real good on the cell phone, except they allowed Nokia, Nokia flew their cell phone business into the ground. They didn't make smart cell phones. They had engineers that were hired by Apple, but they had engineers that wanted them to put smarts in the cell phone, and Nokia wouldn't do it. Their management said, we own the cell phone, but they had, at one point, they had 85% of all the cell phone business in the whole world. And so the department manager of that area wouldn't let them have smartphones. And so what happened? They lost the whole business. Right. They're toast. Right. But it's, in big business, you can only make a few little mistakes. You can make some, but there's key mistakes that'll get you.
Competition's waiting for you to slip up.
Oh yeah, they're right there.
Right.
The sharks are circling.
Well, speaking of competition, that's one of the questions I was going to ask you is, with the home computer, line of products, to what extent were you aware of the competition, and how did competitive forces drive some of the design and what happened with the home computer line? Was there much awareness of, you mentioned the Apple.
Oh yeah, in terms of, like, while we were designing the home computer, that was when the Atari Pong game came out. The very first Atari Pong game that was delivered to a merchandise business in Atlanta, and they were one of our big calculator customers. So the day that product showed up, the next day it was counter to counter to Lubbock and was sitting on my desk. And I looked at it. I let our software guys play with it a little, and then we took it apart to see what they were, and then we sent it to Dallas, where they do analysis for if there's failures. They'd like to know what failed, so they can actually etch down and look at the individual chips. And it used a 6502 high performance processor, but they called it an Atari. It had an Atari label on it. But when you actually, and it was in a 28-pin package rather than the 40-pin package, because they didn't need all 40 pins. So they had a special version of that one, and when I etched it down, I mean, it even had the initials of the designers on it. It was within a week, I had a picture of the mask to make that chip. I could look at it, and it only had like 1,000 gates on the whole thing. So it was a pretty streamlined chip. And but yeah, we were looking at everything, anything and everything. But we thought we were, leading the pack. I mean, all we had to do is just keep going, and it just, a couple wrong turns. I can guarantee that if my boss had been around, we would have never raised the price. I never dropped the price to $100. What he would have done in any case, even if he did decide he wanted to sell it for $100 for a little while, what he would have done is said, we'll sell it for $150 and have a $50 rebate.
Of course.
Because what he told me was that only 50% of the people ever use a rebate. So it means that you're only paying back $25.
Effectively.
And that would give me time to, I wanted to design a replacement for the processor because I didn't want to be stuck forever with the 9900. So I had a processor design, and I had the money. I had 50. Let's see. I think they gave me $50 million to build a new processor, and the Lubbock manager wouldn't let me use it. He wouldn't give me any people. The people were busy making calculators, and says nobody's interested in computers. That's just kind of a sideline. We need to use all of our designers building our new calculators. And so I sat there, and finally, Lynn just threw up his hands and left.
Lynn being yours?
Lynn Donahoe was my boss.
Oh, okay.
And he just, it reached the point that he just retired. He went down to San Marcos and opened up a little coffee shop with a library of technical books so the students could wander in and read technical books and buy coffee until he died. And I would have, because of the move, the president came out, called me into his office and said, as of today, you now report to Dallas in the research, the head of the vice president of research.
This is when
the guillotine came.
Yeah.
And that's that. Then I was there at the Central Research Lab for a while, and then I went to military products, and then finally I decided, as the business kind of turned down, in 90, the semiconductor business was in one of their slumps, and so they gave a really good retirement package. They extended, I wasn't eligible, I didn't even worry about it. But I got a letter saying that we will extend for 4 years you on leave of absence and give you 4 extra years of retirement if you want to leave. And I looked at it. I was up with the Boy Scouts. I'm a scoutmaster. I've been a scoutmaster since '80. I'm still a scoutmaster here in Lubbock, in Austin. But so I was up at Philmont in the scout ranch there with the troop. And when I got back, this package was in the mail, and I had to turn it in within a week, my decision. And so I looked around. I needed a job, of course, so I ended up, one of my students was Dean of Engineering at Connecticut, and I went up and was thinking, he offered me a job, but he couldn't pay me what I normally had been getting. But he could get, not a disaster. And then while I was there, I decided, I'd call the Applied Research Lab. And I talked to my old boss. He said, hey, come down. We'll give you a job.
Here in Austin?
Here in Austin. Okay. Yeah, so I was at the Applied Research. I just flew down there, and he offered me a job. I accepted it, turned the package in. I went home and I accepted the job. I flew down on Friday, accepted the package, turned my stuff into TI on Monday, and here I am.
That was it.
And I still work 1 hour a week, and I don't even turn the time in because it's more of a pain to go through the payroll system for 1 hour of work a week than to get paid. You know, but I go and consult 1 hour a week every Friday.
Yeah, currently? Or?
Currently.
Oh, for TI? Or?
No, for Applied Research Lab.
I understand. Well, yeah, one of the reasons I asked about the competition, and I may have briefly mentioned this to you, is that, you know, in the years since many of these pioneering 8-bit and 16-bit computers came out, you know, one of the narratives that a lot of researchers have looked at was that the interplay between TI and Commodore computers. And Commodore, of course, you know, they had a line of home computers. And what's interesting is the link between the two, because Commodore, I'm sure you're aware of, was a calculator company. For most
Right, yeah, exactly.
And TI was their main source of semiconductors for their calculator products.
Right.
And it's been reported quite a bit that in the mid-70s, I'm not sure if this was a strategic shift on the part of TI, but they decided to essentially allocate the parts, they reduce the number of parts they were selling to third parties and raise the price dramatically on those parts. So this being kind of a strategic threat to Commodore's business, Commodore decided to enter the home computer market, and they went and bought MOS, who had designed the 6502, and MOS became their in-house semiconductor design, division. And so one of the things that we see now, many years later, is that Jack Tramiel, who was the head of Commodore, he really never forgave this kind of crisis that was created by TI and the supply relationship. So when Commodore started becoming a big name in home computers, they aggressively were cutting the price. They were their own fabrication. I mean, they had their own fabs, courtesy of what they had done with MOS. So a lot of the price cuts that we know about in the TI home computers were driven in response to Commodore. For instance, the VIC-20 computer came out in 1980, and the VIC-20, within 2 years or so of its release, had been cut to $100. So
you see, we were ahead of Commodore.
Right.
We were, we started the project in like '76,
right.
And had now the first problem we had was the TV. We wanted it to be in the home. We wanted a color display. The color display costs more than the computer.
Right.
And so we looked at what we do. Well, you can take a modulator and modulate and put it in the computer. That's what we ended up doing too. Well, it turns out to get FCC approval takes over a year. It takes a year and a half. So what we ended up having to do, I mean, we were ready to ship the computer. We needed something to display it on, but it was going to be a year and a half before we got approval of the modulator. So we went to talk to the various people that could make a monitor. I mean, the TV set, it's almost trivial to have a modulator and a external input to it. But none of them had it. None of them had it. So we went to Zenith, and they said, well, we can just take the basic color computer and display the TV and make it a monitor for you. And so we sold the computer with the monitor to get a computer out on the market. And so we were still ahead of Commodore at that point.
Right, of course.
And so Commodore actually came along after they weren't even, I don't think they were even considering a thing. The thing is, all the stuff that they were, that all their interaction with TI was with semiconductor.
Right.
Now, semiconductor was a thorn in our side, put it that way.
Sure.
Semiconductor they were not cooperative hardly at all. The only thing that they did well was they were building a chip. They were working on a chip for Milton Bradley, because Milton Bradley wanted to have a color game that had all neat stuff. The sprites came down, and they had this chip, this vector dot processor (VDP) chip that Carl Guttag is the designer down there. And so what happened is we needed a color processor too, and so that VDP fell right in line with what we could use, and so we worked so that it could meet whatever Milton Bradley might want it with it, and it could work in the home computer.
Right.
And so it was our job to drive the specification, but still, as I say, semiconductor was not in any way cooperative. We had to build the simulator to show whether the chip was going to work right or not, because we weren't. They said, "Oh, we don't need to simulate it. We know how to design it." And so Lynn, my boss, said, "Build a simulator and check it out." So we built a simulator and we checked it out, and sure enough, the line number was wrong by one line, which meant the whole thing would just roll. And so we did find the problem, and we got it, the information to them, and they fixed it, and everything was fine. And the other thing we did is insist that it has the external video input, because if you have a video machine that you want to feed and have an overlay on it, we can do that overlay for you. And so they have that as part of the chip.
Right.
And then I had to fly to England to talk to them about their TV isn't the same as ours. You probably know that. Yeah. They have the PAL. Now we aren't going to try to make it compatible with CCAM, the French standard, but the PAL is, all the rest of Europe, only Russia and France use the CCAM, which is just the weirdest, most complicated color scheme you can imagine. But PAL is phase alternating line, so that you have one line, one color, and the next line is the other color, and then you have the brightness. And in the, of course, what they say over in Europe is that the NTSC that the U.S. has is never the same color. That's what they called it, which it was almost, but not quite. In any case, we're having a semi-adversarial relationship between the Lubbock and our consumer and semiconductor. Right. It's just, they're the only way we get them to cooperate at all is by going through the president of TI and getting them sent a directive that they will do that.
So semiconductor would never design, say, a bespoke chip for the home computer or consumer product division? Is that kind of what you're saying?
Right. They would not.
Yeah, you had to take whatever designs they already had or had in progress.
Well, if
adapt.
we, as I say, we got an agreement on the video chip by the executive vice president flying Lynn and me to Houston and negotiating with them, and we finally came out with, we had to use it, but they had to meet other requirements. Right. They had to cooperate with us. They had to make the VDP so it worked with us, not just a product for Milton Bradley. Right. So, the executive vice president could tell them what to do, but you had to go all the way to that level. Right. To get any cooperation.
Yeah, I thought it was interesting what you said about the TV for two reasons. One, Tandy Radio Shack, who, I'm sure you're aware of this, but 1977 was kind of a banner year for home computing.
Right.
That's the year you had the Apple II, the Commodore PET, and the TRS-80 machines. All three of them came out the same year, and all of them sold very well. And had their strengths and weaknesses.
Yeah, Tandy wanted to use our machine.
Right. Well, I was going to say, because Tandy actually took a very similar approach. They could not, wait the time it would take to get a monitor certified, so they approached a television manufacturer who essentially put a new, box on it and reskinned it as a Tandy product, but it was a RCA television, essentially, off the shelf. So I thought that was an interesting point, but a question I had, though, TI at this point, my understanding is the 1970s, TI had a lot of offerings in the terminal products. So
yeah, right. Yeah, sure.
Terminals. So, was it not considered an option that you could have used one of the monitors that was sold with the terminal products as the home computer monitor?
Well, they didn't have a color. We wanted color.
Oh, they were all monochrome.
Yeah, and Tandy wanted to have as part of their product line, they'd like to use the home computer. Unfortunately, there was a rift between Tandy and TI president. He made a comment when he was touring at TI and made the president mad, made Busey mad. And
Charles Tandy.
Yeah. When he was commenting on the expense he had a tour of the military products, and they build Cadillacs, they build fancy stuff, but it works well. They got some stuff, but he made a derogatory comment because he's in the other end of the business, the lowest end, and the military products are in the highest end, and you just got to understand the stuff. Anyway, it irritated him, and so we were forbidden to deal with Tandy. Just said you can't do it.
Yeah, well, and that's very interesting too, because the reporting, or what's been written out there, is that Tandy approached many different companies about producing their home computers,
right?
Including Jack Tramiel at Commodore. At one point, they were approached asking if Commodore could design the home computers for Tandy as well. So it was,
No, we would have welcomed it.
Yeah.
And that would have been a good. But we had a strong enough position with the 5 different areas that we're going to work with, that if even 3 of them were fully successful, we would have been the IBM of home computers.
Sure. There's been some videos that have come out in the last year or two that look at. Are you familiar with Morris Chang?
Oh yeah.
So, and specifically looking at his role at TI, because from what I understand, he was head of this consumer products project or division, and now the kind of failures or challenges he met with that division was one of the reasons that he left and formed TSMC. So, did you ever meet him? Was his influence?
Oh yeah, I have had lunch with him. He used to come out on a regular basis. He trained me in the course in quality control personally. So that I could teach quality control in Lubbock, and so everything was going good. The problem was he got sidelined because he was actually the next in line for president, and other people managed to get him sidelines, and they had another guy that was close in there too that got sent to become manager of TI Europe, all of the European, in France, Italy, England and Germany, all of those things. He had, but it got him out of the line so that he wouldn't be a candidate. And so at that point, then the untimely death of Haggerty is what really killed it all. You know, the other guys that were fighting to move up, it was pretty dog eat dog in the management area, and so some of the good guys got sidelined, and Morris Chang was really, he was a great individual. I mean, the local manager in Lubbock, the one that wouldn't let me have money, he never ate in the cafeteria whatsoever. He scheduled a business meeting in his office for lunch every day, and he was retired from the military. I think he was probably been a major or something like that, and he, I'm sure, carried a swagger stick, and but he was not amiable to, you know, he just didn't have the right vision of the technology of what was going on. And my boss liked to work and didn't keep everybody informed. Rather than trying to spend all the time necessary to convince management that you're doing the right thing, just go do the right thing and they'll see it in the aftermath. And so he did that again and again. But some bosses really get irritated when they weren't informed, even if you are doing a great job. Right. They just feel that cutting them out of the thing so that you can make quicker decisions is not the appropriate way to go, and probably in the long run isn't. But that was the way Lynn worked, is I do my thing. You see, you know, he developed the TI-50 that competed with the 35, you know, as his product. The guy that did that design, of course, died of cancer, and that's who I replaced. Okay, the engineering group, after the home computer was finished, and the 99.4 started out, had the monitor, of course, doubled the cost, but a number of them sold, but it was not a home system yet. It wasn't home priced. Then we got the modulator, and that got it going, and we had the 99.4A. It had an expensive keyboard for a while, or it had a Clixon type keyboard, calculator type, you know, keys, and they got our mechanical engineers designed their own keyboard technology. Gave us a low-cost QWERTY keyboard, and so then we had the 1B with an improved keyboard, no monitor, and everything was trucking along. And so the engineers then that were available wanted a computer of what they would like to have, one that they can carry around with them, a portable. Well, I mean, you have the that great big portable one that weighed 30 pounds and was the size of an oscilloscope. You remember the guy went out of business because IBM announced a portable computer, and he said, I've got one that's going to be better than that.
Oh, was it the Osborne?
Osborne, yeah. And when he announced his new machine, when he announced the new machine, sales went to zero, and his cash flow went. He had a pretty large manufacturing because he expected it to ramp up, and he wasn't prepared for it to go crash. And you got to be prepared for these things. Various things happen, and you don't announce your product early unless you are prepared with something else. Right. You know, because your current product, you just killed your current product when you announce a new improved. Right. If it's significantly improved, I mean, if you come out, and if your new car has twice the horsepower, but it's not available yet,
Right.
you don't dare announce it because the other car goes to zero.
Right.
I mean, nobody in their right mind is going to buy something that's going to be obsolete within a year.
Right.
And so, but he did, and he went out of business. But that was the only portable machine, and so they wanted a portable machine, and they were interested in the machine that they wanted of that kind. And so the CC40, Compact Computer 40, which is battery operated, it's got 4 batteries fit back here, just little small batteries, and it's got a 40 character LCD, because in those days this is as big of LCD as you can get.
Right.
And it was I think designed to cost, was put it at a good selling price of $250. So it was like $50 more than a scientific calculator, but it was a full computer with a keyboard, and it could do text editing because the text line is 80 characters long. You only see 40 of them at a time, but you can shift back and forth. You can do the modification. So you can write a whole page of text. This thing's in your lap. You can fly with it. You can almost put it in your pocket, not quite. You can put it in your coat pocket.
Right.
And so this was designed by engineers for engineers. It has little plug-in modules of their own software here. It has peripherals that run on a bus that is very similar to Apple's 6-pin bus. It was a 6-pin bus. They call it the hex bus.
Okay.
And of course, the Hewlett-Packard had the USB, and they didn't charge anything for it. They let everybody use it. And so it became the industry standard and wiped all the other buses out. But those buses weren't available. Hewlett-Packards didn't come out until, I think, must have been 88, maybe.
Or is it are you talking about the GPIB, the General Purpose Interface bus from Hewlett-Packard? I know that's a bus they use on many of their...
No, I'm talking about the USB.
Oh, okay. Because that came out in the mid-90s, 95, I believe.
Well, it was they had it undercover earlier than that. I was on the military computer group, and for 2 years they were on the agenda to describe their bus, and they were a no-show. They wouldn't do it, but they finally did. And then, but this hex bus came out before we crashed, and we had a 6-pin bus that could hook up all kinds of peripherals in that same fashion. It's just that if you're not in the computer business, you can't use it. So it, died on the vine. But it was a bus that we could hook up all kinds of peripherals. We had these little plug-in modules that had a business module, a math module, and software modules, and it really, and it still works.
And so was that product, was it a good seller from the start, or?
Well, it was just getting ramped up. Yeah, it was. I don't know how many they sold total, but it was going good.
But it was affected by the exit from the.
Well, yeah. When you go out of the computer business, this I'm not sure why, but they were really nervous, and they were all semiconductor people making the decisions, so they didn't. Well, the people in the scientific calculator side who had the 59, this would actually probably impact negatively the sale of the 59 calculators, and so they weren't interested in pursuing it. They could have changed the name from computer to calculator, and they could keep selling it.
Well, right. That's why I was interested in it, because I would think if it could be rebranded as a much more capable scientific calculator, that it would have survived that culling of the home computer products.
But our whole computer group had been dispersed, and the calculator people were interested in their they're the ones that stole all of the circuit designers. There was one circuit design group that served the educational products, the business products, and the consumer products. There were three calculator divisions, three separate calculator divisions, and then the computer division that we had. So there's four divisions. As far as they were, this competed with their products.
So there was no one left to advocate for this.
That's right.
Yeah.
And we had all been sent off. I had 40 engineers eventually, and I placed some of them in the TI office in Colorado, some of them with the military products in Louisville, some of them down in Houston, and then I went to the Central Research Lab, and then it was the problem, with all research labs. They hang on to the product too long. Because they see that just about the time that you have a working product, you see great improvements, and you can't resist going and pursuing those improvements instead of productizing what you can do at just the right point. You got to freeze and sell it. Well, the people in the Central Research Lab, they took the deformable mirror, which is, you saw all the TV sets that TI had for a while. With the only thing it's used for now is in projection TV. They're still making a lot of them. TI still makes the product, but they took an extra at least 2 years not productizing it when they could have. They didn't even realize it could be for. I have the patent. I actually personally have the patent in my name to do projection display, because I was going to build the next generation of home computer with an 8-bit custom processor that ran like a Banshee and a projection display. So you folded up the screen and it displayed, but you internally automatically corrected for the parallax of the screen not being straight up in front of you. You had the screen shooting across your thing. But that was my next product out, which it'd take a few years to perfect, but that was where I was going, and when everything all crashed. But I actually ended up with a patent that says if you use the deformable mirrors technology for projection, that's my patent.
Very interesting.
And I also have the patent for all of the little plug-in software, that interface that's used to get the memory off of a stick. I have the patent on that also.
Interesting.
They actually gave me some money after I left TI down here because of the value of the patents. Not much, but a little bit.
Sure. So I want to jump around a bit. When you retired or left TI, were you a TI fellow by that point, or?
I was a senior member of the technical staff there. Lynn wanted to make me a fellow, but the next level said the senior member of the technical staff was a brand new position. It didn't exist before. They said, let's do that, because in a year or two we can then make him a fellow, and so that'll keep they'd like to move me up the chain. So I ended up being a senior member of the technical staff, but my pay scale was more than 60% of the fellows.
Right.
they were paying me at the upper end of the maximum, and the average fellows are at their midpoint, and their midpoint was below what I was making.
Yeah, I asked because when I interviewed Carl, and he got a little bit into how the TI fellow system operated, and being a consumer and just an enthusiast, I wasn't very familiar with how TI had structured that program, and so yeah, I was kind of surprised he mentioned how the fellow program and how you kind of reached to become a fellow. There were a lot of extra levels that got added in the later years, and Carl said he was the youngest fellow because he achieved that before they added in all these intermediate steps, and it was just very intriguing to hear how that whole system worked and how TI tries to promote and encourage growth.
Right. Yeah. That was part of the system, and I was in kind of that chain when I went to the Central Research Lab. Then I was moved me out of the chain. I got a incentive award every year until I was transferred to Dallas, and I had the incentives from Houston. They kept me on LOA instead of just closing me out when I left TI, so that I could get my deferred incentive awards. Because at that time, it took you would get one, and then another third, and then the third year you'd get so it was distributed over time, and I had pending awards, and so they set it up, and I consulted during the summer, and then the supervisor that replaced Lynn was concerned that the engineers wanted me. The position was open. They wanted me to leave Missouri and come back as the department manager. And I said, I'm in the middle of teaching classes, and the classes that I teach, I don't have a textbook, because the textbooks are lagging behind the technology. And so I'm teaching the technology that's beyond what's in the textbooks, and I can't just say, oh, goodbye. But they need somebody, they might have waited a month, but that's long as they would consider waiting with an open position like that. And so the guy that did take the position was concerned, and so he got my consulting contract terminated. He went in and finessed it. He claimed I wanted a raise, and it was going to be too expensive, and the guy said, yeah, and just wiped it out. And so I no longer, because I was planning to consult most summers. I'd go down to Houston, to TI, and consult in the summer, and then on the 9 months I could go up and teach. And that was my plan. And I did that one summer. I came down and I spent the summer in Houston, and then I went back to Missouri, and then when I tried to come back, they just killed it.
So going all the way back, so how did you really get started with electronics? I mean, what motivated you, or how did you get interested in electronics?
Well, when I was living in I was living with my grandparents, because my mother died. My dad's a field geologist. He spends half of his time or more out in the field. So I lived with my grandparents instead of with him. And my grandparents, when my uncle came back from the Army, Army Air Corps, he flew B-29s over bombing Japan. But when he came back, he was having local problems with girls and school and everything, and he decided, my grandfather decided, let's just all move to Arkansas. So we moved to Jasper, Arkansas. It's the county seat of Newton County, 500 population, not a paved road in the county. It takes an hour to drive 20 miles from Jasper to the closest town, which is Harrison, over these little winding, bumpy roads. And the guy that plowed our garden with a mule, we asked him about, what's over in Harrison. He said, well, I don't rightfully know, never been over there. He was 60 years old. And in 60 years, he'd never left Jasper and gone to Harrison. He said, a lot of people go, but they come back, so there must not be too much over there. No reason to go. It was interesting. Well, while I was in school there, I was interested in various things, but my uncle was going to school at Fayetteville, and he was trying to look for a Christmas gift, and he saw in the window a Howard communication receiver. Okay. Has multiple bands and had the beat frequency oscillator, and it had the automatic volume control, the AVC, had all these things, but I didn't know what they were. So I sat there, and I was talking to one of the classmates, and they said, well, there's a guy that used to live in this house that we're in that had left some books behind. The reference data for radio engineers and the amateur radio handbook. Mm-hmm. One of them had covers on it, and the covers had even been torn off. But he said, but they're really trashy books, but if you want them, I'll bring them to school and you can have them. So I got those books and I read through them to figure out what all these controls on it was, and the more I read, the more I learned. So I read cover to cover both of those books multiple times, and learned enough so that I could anytime I had problems, I could fix it. Now, I did a few things. I set up, we were down in a valley around the mountains at Jasper, so you could only get a few radio stations. But to get the best long distance, so you could get Voice of America and the Radio Moscow, that you have a big long wire antenna and a good ground. Well, my ground, I ground it to one of the springs of the double bed that was in the bedroom, and unfortunately the leakage there's a capacitor to get the noise off of the power line going to ground, and if there's a little bit of leakage there, it leaks into the ground connection from the radio. So the springs were hot. Not dangerous, but hot. So they shocked my grandmother. But I was, into that, and I was, listening to all this long distance stuff and still reading everything I could in the book. And my instructor, seeing that I was scientific oriented, would get all of the science books. I was in 7th and 8th grade with her, but she would get all the science books that weren't. They would send like 3 different copies of the book for general science to the school, and the school adopted one, and so the other 2 were there, and she would just give them to me to read.
Yeah, the evaluation copy. So
I read all of those books, and then halfway through the 9th grade, my grandfather had a heart attack, and we had to move to a lower climate. So we moved back to Corpus Christi, and in December. So in the spring, I went to the country school that we left, which was not a really good school. But I took, and they said, well, your general science, we had all this stuff, we had a workbook of all the science that you missed. And I said, oh, just let me have the workbook. And I went home and over the weekend filled it all out and turned it back in. And so they let me go ahead and take the second half of the course because I'd already completed all the first half over the weekend. Sure. And anyway, that was what I was doing there. Then I moved to the W.B. Ray, which is a big high school in Corpus. Like there were 700 students in my class. And we had a science club that met every month after school. And we would have, and so I had a project to use for the science club, and I built a ultrasonic generator. I built a big 350 volt power supply and a oscillator, high frequency oscillator that my physics teacher gave me a few pointers of information to do it. And I built that, and I got a quartz crystal and went over to the junior college. They had a lapidary and got it cut. And I cut it to build an ultrasonic system so that I could demonstrate that for the science project for display. So I was, kind of, and I had, had a crystal radio. The first a 1N34 diode when it first came out, and I think it came out about 51 maybe. I immediately, it was $1 a piece. I mean, it's a lot of money in 51, but I scrounged up $1 and got that, and you could make so much better crystal radio with a quality diode.
Using as a detector.
As your detector, right. And then with the crystal radio, I could pick up, occasionally I could get, like the Phil Tower in Tulsa, the 50,000 watt station, WVOO, and get the New Orleans station and the KOB Albuquerque station and the Denver station, the 50,000 watt stations.
Clear channels.
Clear channels. And of course the 100,000 watt from Mexico, XCRF, and while they were doing all their ads to con ads, they were just across the river it said, if you're really hurting for money, go borrow some, send it to us, and we'll pray for you.
The cons are creative no matter what era they're in.
Oh, yeah. So it was a lot of that electronic work that got me the job on the analog computer. And the analog computer, I learned the equivalent of 2 or 3 courses worth of information, just because my job was to make it work, but not only make it work, but to show people how to use it. So the people from the chemistry department and chemical engineering would come out to run problems, and we would help them set the problem up, and so I was so far ahead of everybody else in the electronic stuff that in my, right at the end of my junior year, they put me in, they nominated me for Tau Beta Pi to the engineering. The electrical engineering is Eddie Capanou, but I got into Tau Beta Pi earlier because the guys over there who were graduate students said, you know more technical stuff than we do. He says, you have to learn it. But he gave me books to show how to use analog computer and how to set it up, how to work problems. And so I had all that experience on top of my school classes. So I learned, just working on that one project, I learned the equivalent of about 4 different courses. Right. And that put me kind of ahead of the game. So I stayed for my bachelor's in Because I was in ROTC, I didn't graduate until August, but I did graduate in 4 years. But it was just exactly 4 years. And then I jumped straight into graduate school. I'd reserved one summer class for graduate school in my numerical analysis class, and went to graduate school. Took all of the courses there, and then I did a master's thesis at the Defense Research Lab. That was a variable bandwidth constant K filter. I took vacuum tubes. Before the transistors were all coming out, so I used vacuum tubes to design a filter that you could change its bandwidth. You have a knob with the right resistors, and you could you didn't have to use inductors. You had a synthetic inductor done by the vacuum tubes, and so I built that filter unit as for my master's thesis, and presented a paper on it at the IEEE because I wasn't absolutely certain that I was going to stay and do my doctorate. That was a long-term plan, but I was still keeping my options open. So I thought I'd just go ahead and do it, because I was already at a place where I was building the equipment for doing experiments in the acoustics there at the Defense Research Lab. And so after then, my supervising professor had a funded NSF program for initially we were looking to see, I took a bunch of courses in nonlinear differential equations for whatever. I just sounded like if you learned enough about that, it ought to give you some tools. As it turns out, those aren't the sharpest tools in the world. I mean, they're a lot of work to use. But anyway, I was going to see if I could do a three-dimensional phase plane, and I worked on that for months and months and months, and I just couldn't quite get it all together. So the tunnel diode was out, and there was a question as to whether if you took a tunnel diode, it was, it operated at really good real high frequencies, and it was, it had the nonlinear negative resistance region. And so the question was, if you cascaded tunnel diodes, can you get a higher gain bandwidth product out of it? And so I did both experimental, where you take the tunnel diode and you take big blocks of aluminum, because if your lead gets more than a 1/16 of an inch long, it starts to oscillate. And I went into a screen room, because TI, right in the middle of my work, opened up the KUT on the tower. Their antenna was right on the tower, and the windows in the lab open right up. You can see the tower looking out of the windows. So I had more signal from the tower than I had in my circuit. And so it just so happened that there was a screen room just at the end of that particular lab. And so we just went in the screen room, closed the door, and did the experimental work, where I did both experimental and analytical proof that no, it's essentially the same. It doesn't matter. You can't go and take a whole bunch of tunnel diodes in cascade and get an improvement in your performance. And so I then wrote that up, and that was my dissertation. In the meantime, he left UT and went up as a chairman at University of Missouri, and I graduated and went to Houston and did that series of products, both the seismic ones and the mini computers. And one other project I did, which is the military. TI had a pretty strong military products group, and I don't know what problems they were running, but they, while I was there were one of the PhD in the geophysical department sent me a paper that I might be interested in. The title was Cooley-Tukey algorithm. It turns out that is a algorithm for the fast Fourier transform. And so I read it, I think, through 3 times before light bulb went off. Hey, that's a fast Fourier transform. And then they were looking at, they needed a system. And this is kind of like I had a gap where I wasn't on a super short schedule where you have nothing interferes with what you're doing, but I had a little bit of a gap. So they came down and said, we need something that takes and computes Fourier transforms on 40 channels of data at 1 kilohertz data. So we got 40 channels of 1 kilohertz data coming in, and we want to take and do 40 fast Fourier transforms. We want to do a covariance matrix, which means that you multiply all the channels times all the other channels and create an array, 40 by 40 array, which is the upper and lower part are identical, so that you only need to count half of it. And then you stack it with a decay coefficient and add the new one in. And that's we want that as a processor. Build this one. So I built the first fast Fourier transform hardware, and that did that. Now because the memory was limited, we couldn't put 2 buffers, and so I picked an algorithm that we could do in-place operations, but it scrambles where the data is a little bit. And I had an engineer working for me that he and his wife had worked on the Whirlwind computer back in the early computer days, and he said, it can't be done. And then I worked out the computational algorithm to allow us to use half the memory. We did the multiplier. I call it a crunch multiplier. It means that you don't do a multi-bit or a 2-bit or a 4-bit. You do a 16-bit times 16-bit. Just put the 2 components in, and out comes a product. And you have a stack of full adders. The semiconductor guys were just going gangbusters, so they had 2 full adders on a single chip. And so you have a row of stacked full adders which add all of the components together. We do a recoding which cuts it in half, so you only need 8 inputs. And so we had super fast multipliers. And so we multiplied all that stuff. We had a drum to stack it all on, and built the thing up. And I just recently talked to one of the students that got his PhD. He was in the dormitory where I used to live, and he lives here in town. He's retired, but he said they may still be running, but they ran that for years and years and years, processing data, and I still have no idea what data they're processing. Sometimes I think it's for this program or sometimes for that program, but it just disappeared behind a wall, and apparently it was super successful for them.
In the military.
For the military.
Yeah.
Anyway, that's kind of takes me up to the point. One project that I almost did was there was a company that wanted to build a machine that would run the code that's run on a UNIVAC 1108. They had like 10 of them, I think, or 8 of them in Dallas. And they wanted a machine that ran 10 times as fast. And so my boss was dealing with them, and he asked me about it, and I said, yeah, we can do that. I can do that. But the corporate looked at the company, and the company had shaky finances. They were marketing and selling, it was a service company that does processing for people. And they were doing all kinds of advertising and spending a huge amount of money. And they, instead of paying for the amount of advertising, one of the things that a company on a sound financial basis doesn't do is to take it and pay for it over a 5 or 8 year period. You don't let your marketing, you may let your new hardware be paid for over a 5-year period, but you don't let your marketing be paid for over a 5-year period.
Amortizing the marketing. Huh?
That's amortizing it, and that's what they were doing. And they said, we cannot afford to get tangled up with a company that's amortizing their marketing, because there's a good chance that you'll build this product, and before you ship it and get your money, they'll be out of business. And so I didn't get to do that. And I didn't get to do the new computer because the military computer group had finished what they were doing for military, and their whole computer group was available to do the new processor. They was going to build a new supercomputer that could run circles around a cray. And instead of letting us do it, they gave it to the military computer group. And they made it twice as expensive and twice as long to build it as they should have. They shipped 1 or 2, but it's we didn't get to do that. And so it's when that happened, both Lynn left, I left. You know, it's just this being in Houston, and the management decisions are up in Dallas, and of course the military computer people were right in the same building as the top management, the North Building there in Dallas. So they've got the ear, and they've got, you know, they can cut you down, and so that.
Do you remember what the that computer, like what its model number was, or any?
ASC, ASC, Advanced Scientific Computer,
Okay.
which they touting for both seismic and scientific applications. And they were using the fastest emitter coupled logic that TI could make. They were putting it on boards that were cooled with power steering fluid. I mean, you could see military computing not thinking coming out all over the place, because occasionally it would spring a leak and they would get power steering fluid all over everything. And they actually, that whole project got moved to Austin, and they were building it off of Lamar Boulevard in a little building during the Vietnam conflict. And the students knew that there was military work that went on there, and they firebombed the building.
Wow.
And that's when TI moved to the stuff out near north of Duval, out that whole complex. That TI had a whole building complex where they did the mini computers and everything. And if you don't have the right perspective, I mean, there's a difference between the way you build military products and the way you build commercial products and the way you build consumer products. It's 3 tiers of capability. And, you gotta understand, and all of the people that were doing that major work were all didn't understand the commercial or consumer level. They used too many screws to hold things together. Just you got to count everything.
Yeah, overbuilt it.
Yeah, and it's kind of like the example that Lynn Donahoe would say is that the TV manufacturers, it's a competitive enough business that they go in and remove every resistor to see if it has any effect. If it doesn't have any effect, they leave it out.
Right. Well, a friend of mine who actually was a Tandy engineer for a long time kind of relayed the same idea. He said, management loved me because every time I would cut a component that wasn't absolutely essential, given the scale at which you're selling consumer products, said, I just bought those guys a Ferrari by saving that, half a
That's right.
resistor.
Exactly.
So management loved that.
That's right. That's the way you've got to think at the consumer level and competitive. And that's what, Lynn taught me we were doing to have that mindset.
What would you say that you're aware of has been your most successful product or maybe a project that led to a product? I mean, is there one throughout your entire career that you know of as being the most successful, whether that's commercial or could be influential in, either engineering or technical circles? I mean, what do you think is a product or project that's had the most impact?
Well, the one would be, while we were building our seismic computer in Houston, and particularly the upgrade, the Dallas group had decided that they're going to build the 870. It was a 24-bit computer, and they built the whole thing up to deliver to GSI. GSI looked at it and said, it runs a lot slower and costs more money than what Houston's delivering. He says, we won't accept it. So the president of TI, I think Busey was president, he may have been the executive vice president at the time. Anyway, he took that computer, put it on a truck, and put a note on it and sent it to Austin, sent it to Houston. And the note said, fix it. Nothing else, that's it, just it, fix it. And they did send some engineers, but I was responsible for architecting the fix. And what I did was I built and patented a pipeline processor, which had it could do, it's a 24-bit machine, and we do a 2-bit recoding, so we've got 12 steps. And you run this thing through, and that you run it at its absolute maximum speed, so that every step is the speed of the fastest memory that you can put in the machine. And that as its core, and then you put a big disk on it, so that you have a lot of good storage, and you make the whole thing set up so that it is streamlined and running at its fastest speed. You have some big instructions that allow you to do something like you can give a filter instruction, and it will modify the filter halfway through the filtering process. It'll take you just give one instruction, and it will provide a filtering at each stage of the way. And so it became a fast machine. Eventually they, as faster machines came out, if they built the ASC like it should, the ASC would have taken its place. But that machine then ended up being quite fast. Not the fastest in the world anymore. I mean, the Cray was probably the fastest one at that time. But a close, not far behind. And it ran the seismic centers that were using it, continued that machine until probably almost up until 1890. And that machine went out in 68, I guess. So from 68 to 90, and there aren't many machines that stay running. And they didn't use it for all of their top main processing, but they used it still, keep it operating, because it runs fast enough to do a lot of good processing. And so that's probably the best long life machine. And it served in all the processing centers. I wouldn't be surprised if you went into one of the geophysical companies and looked at where they're doing their processing. They may still have one of those processors running. Now, the only other thing would be the 860 mini computer, the first mini computer, and the 860A, which by the time it came out, they added semiconductor memory to it. Originally, the first version had a core memory because the semiconductor memory wasn't available yet. But that computer, the last I heard, I haven't heard whether they've removed any of them, but it may still be on the processing equipment up at TI in Dallas.
And that was the 860 and 860A, you said?
The 860A. But those two are the longest lasting and a couple of the best products that I was responsible. Now, I'm obviously not totally responsible. I mean, there were teams of people, I really didn't do anything with the disk other than keep it in the architecture, but plan. They had other people, they had another team that was doing the disk, and the disk was the disk had plates about this tall each segment of the disk, and it had a axle the size of a railroad car axle.
So this is a hard disk.
Hard disk.
Not a floppy, right?
Early hard disk.
That's incredible.
Huge thing.
Is there a project that you're most proud of that maybe wasn't a success? I mean, was there anything you did during your career that was you know, maybe didn't take off, or maybe it was ahead of its time or whatever. But what's kind of your most proud project or product?
Well, the one that I missed was this deformable mirror display, and I got the basic fundamental patent on it, but I never had the chance to pursue it. It kind of disappeared into CRL, and there's another group. The guy that was marketing manager moved over to head that project up, and they keep the marketing manager in the corporate labs for 2 to 3 years. They just take one of their top technical people and make him the marketing manager. And so I was the marketing manager for 3 years. And the nice thing about that is I got to see every single project that TI has anywhere, every one of them. I had to approve every project to see whether it had to be confined to the United States only. You know, they have certain products, like our Speak and Spell, for a long time couldn't go overseas. It was U.S. only. And when it finally did go overseas, you could find it in the cockpits of Russian fighters. The chip.
Yeah. Well,
the French were supplying it to the, because once it got to France, they shipped them to Russia.
But was it, I'm guessing it wasn't an export restriction that would have kept it out of other countries, right? Would have been more of a technical reason of...
Export restriction.
Oh, it was export restriction.
Oh, yeah.
Oh, okay.
There's a book about so thick that defines all of the things that are export restricted.
Okay. So it wasn't a technical restriction, like it didn't have correct phenoms loaded into...
No, it's export restriction.
Okay.
And we, all manufacturers that export goods have to make sure that it's not on the do not export list.
Right. So throughout your career, what part of engineering did you enjoy the most?
I like working with a team. I'm not a lone wolf. I go do it all by myself. I like to work with a team. I like to have stimulating ideas, feed them in, and have the team put together with me. And that's. And I did that same thing up in Missouri when I was teaching. That I got enough money so I could have students. Now, one of the things that was really nice up there is we got a lot of military students. For whatever the reason, it used to be the military students could pick a college, if they were approved to go to graduate school. They could go to college and be paid to go to college. And they make outstanding students and researchers. They're highly motivated, and they're the best. They're the cream of the crop for the military, technically. And so if you can get them, you don't have to pay them anything. They work really hard. And so if you can build a team around with a few of them sprinkled in, and I had some from the Navy and a lot from the Air Force. Now, finally the Air Force has decided that they want them all to go to the graduate program in Dayton, Ohio. And so we didn't get them anymore, but I had a whole bunch of them. One of them, I got him involved when he was an undergraduate. He had a little bit of maybe 2 years, over a year's worth of college, and they sent him to school to get his bachelor's. But he was highly motivated, so he got his bachelor's in like 2 years. And but he was interested in working on stuff, so I got him into our research projects. And so since he had a year to go, he said, well, why don't you let me stay and I'll finish my master's? And they said, yeah, we had already planned on you being there another year, so yeah, sure. Can't lose. And he whipped his master's out before the year was even up, because he had already taken about half the courses that he needed before he even asked. And so he said, well, I've got all these extra courses towards a PhD. Why don't you let me stay for my PhD? And so they said, okay. And so when he finished, they then wanted to see where are we going to sign you. So they signed him to the Air Force Academy. And so he went to the Air Force Academy and taught for, at the end of 3 years, you get reassigned. So he was at the academy. He got reassigned to the research lab at the academy. It was a reassignment, so that's all fair game. He didn't have to move. After 3 years there, he got reassigned to the teaching. He finished his 20 years and retired.
Right.
And I hired him to come to work for us in Lubbock.
Oh, great.
Because I kept up with him. I used to stop and visit him whenever I went through Colorado. So, he's really good. I just got a letter from his wife. He passed away, unfortunately. She sent me a letter I just got a couple of weeks ago. But working with a team on a challenging product is really nice. And if you don't get pushed into the politics, I don't like to get messed into the politics. If someone the problem is, I probably could have maybe headed off some of the political problems if I'd done it, but I try to kind of steer away from the politics. And Lynn did a good job of taking care of that, but when he got sidelined and then quit, that left me out of the going right. And I found that the basic research labs are great, but they don't fit my model of what I like to do. I like to get things and take them and make something out of them, and I like to work as a team. Well, most of them don't. They prefer to work as lone wolves. This is my thing. I don't want anybody. Don't mess with me. They had people there working on, gallium arsenide quantum wells in the 80s. And quantum is just coming to the fore right now. But if you had the right team, rather than it's this guy's special thing, doing his thing, and then he works on that for his whole life, that's not the way I like to work. Sure. And so that's why I ended up going to the military products. I would have liked to have been in an industrial product opportunity, but there really wasn't a good spot. And so I went, and the military products, their products are developed over a time period that's, years and years and years. You start working on it, and 10 years later, your product comes out. And I like to see something that's 3 or 4 years. You've got products that, so you can take this technology, and it's still hot technology when it comes out. These military products, the hot is all long gone. They're hopefully still a little warm, but
well, it's more driven by national strategies or longer-term strategic objectives than market.
Right, and it's just, they go through funding processes, and they go through it's just, now NASA's a little better. NASA has some hot products, and they work until they kind of flattened out. You know, nowadays they're not what they used to be. But in their heyday, they were the right type of organization to get in, get a team, and go make something happen.
Right. Is there an example of adversity that you faced in your career that really stuck with you? I mean, was there maybe a project that, you know, was cursed from the start, or even personally? I mean, was there personal adversity that you faced through your career?
Quite frankly, I've been blessed. Everything, you know, I don't worry about it, and generally it works out. The only adversity was what happened to our computers at TI. You know, that was bad. But other than that, and it is a little painful whenever they yank what you wanted to do away from you and let somebody else do it.
Sure.
Just because you're in the wrong place.
The wrong time, right?
Yeah, but they used to keep me, you know, like when they had a serious problem, they had a project for electronic pictures in Dallas, and back in the mid 80s, back about 80. Let's see, 84 is when we. But probably around 1980, maybe in 80 or 81, about 1980. Anyway, the Pat Haggerty had me. They were trying to build this product which would take electronic pictures.
Like digital photography?
Yeah.
Okay. Like
And
sensor?
it's on a little flying disc. You know, it's an air flying high-speed little disc, and so you got this little disc, and it spins, and you put an electronic picture on there, and then you can. So you need to be able to put the picture on it, and you then read the picture back out. So it's a small little disc. It was a, you know, one of these, at the time, super secret project, and they were having problems. It was too noisy. It didn't have good pictures, and they just couldn't get it. So Pat Haggerty, you know, one of the founders of TI, had me leave Lubbock, go to Dallas, and fix it. So I go to Dallas, and they let me have the best technician that the military computer group had. So the two of us went to that group that was working on this project, and we fixed it. He could, you know, do absolutely spotless, you know, soldering and putting because you gotta, you know, it's just noise. And so basically what I did is I said, instead of trying to make your own amplifier, why don't we take the amplifier out of a TV set and just pull that, you know, they got those amplifier chipsets with all the interface. Why don't we take one of those and we put it on a substrate and let this mechanical guy from the military group put it on in the quietest electronic fashion he can and see if we hook it up that way. And he did. And it was perfect. Beautiful picture. And we took the last picture of Pat Haggerty at the board meeting in Dallas with that system. If you see a picture of him just before he died, that's where that picture came from.
Oh, interesting. From that sensor?
From that sensor.
That's
We took the camera thing and took a picture of him and then played it back, and there it was.
It's interesting too, because I don't know if you've heard about. There's a story about Kodak, in the '70s, where they had an engineer who built what they claimed was the first digital camera system, but they were so afraid of it. I mean, these management said, "Oh, this would kill our business. This would destroy the film business."
Oh yeah.
They had this product, so they shelved it. And I mean,
And that's absolutely true, because I was served on a committee. It was the IEEE Consumer Committee that reviewed all of the papers. And one of the people on that committee was from Kodak. And we would review the various papers that people had. And that's absolutely true, because what we would do is that committee decided that the way they ought to do it is they bring in like 20 people, and then you take all of these paper submissions and you stack them up in each group. You sit down at tables, so you have 4 groups of 4 or something like that in a big room. And you take these stacks of papers and you go through them and you say, well, this can be a conference paper, this ought to be a transaction paper, this one's just throw it away, reject it. And so we'd go through and rate all those papers. And one of the committee members was from Kodak, because he was in the consumer business for electronic things. And so he confirmed the fact that they did have that kind of stuff.
Yeah, I mean, it's been reported. I mean, they
yeah, no, absolutely true. Absolutely true. Yeah, they had that.
One of the greatest regrets as a company that they could have owned the forthcoming digital imaging world.
Yeah. It's just like Nokia had an engineer that had all of the stuff for putting camera on your thing, and oh no, camera costs too much. We don't want to why mess up the thing? We own 90% of the world's market in phones. We'll just cruise on.
Laurels, huh?
Yeah, and the thing is, you make that decision, and within 1 year, you're toast.
Right.
When Jobs, I think one of their engineers went to work for Jobs, and he said, "Hey, we can make this, cell phone." And Job said, no. And he went back, we ought to make this cell phone. I've got all the stuff here, so what we can do. No. Third time he went in, Job said, okay, let's do it.
Right.
Of course, Jobs was a master salesman.
Sure. So
once he saw what he could do, and he probably went in the third time with how much money he could do it for.
Right.
That's so, you come in first, here's what we want to do. And the next question is, what's the cost going to be? How much is it going to cost? And so you got to do what we call a design to cost. And so you say the cost, here's what a person might pay for it. And of course, Job's, what he did masterfully is he would take a product and slide it in as what we call a carriage trade product. You have your elite products, and elite products are just a little high. He'd go in with a carriage trade product. The Apple computer was a carriage trade product. The Apple computer cost more than any of its competitors, but it was better. So the carriage trade, if you want to get the best computer, you go get the Apple computer. And so each time they came out with something, they came in with something right that the carriage trade would go with. And then you get enough volume on it and you just push it down into the consumer market. And so that's what he did with the cell phone. He had the music that joggers can wear.
Right, the iPod, right?
The iPod.
Yeah.
And all of that sort of stuff. So but the market, if they had not come out with either the iPod, 1 year later, somebody else would have an iPod out there.
Sure.
I mean, the opportunity was right then. And if you do it quick, that's the other thing, is don't decide that it's a good thing to do and then take 2, 3, 4 years to get it done.
Right.
go do it like we did with our seismic, so we could get North Sea data and put it in business. At one point, I think they had 8 or 9 ships. They actually owned a fleet of ships sailing along, firing off. They just figured better and better ways to. They had a air gun was a final method. They would have different barrels, lengths of pipe, and then you would have a compressor that compressed, high compressed air. Then you just open it up and shoot a huge amount of compressed air into the air guns, and the air guns send out a sequence of frequencies that are on the range that you're looking for with your sensors. And so it goes boom. And so they could just sail along and go boom, rather than throwing over sticks of dynamite, which kill fish and
probably broadband,
right.
Lots of different frequencies you don't need.
That's right.
Yeah. If we can back up a moment to Haggerty, I mean, it seems like you and him had somewhat of a close relationship, or you knew each other, right? I mean,
yeah, but he was brilliant, I'll put it that way, and he had all kinds of ideas, but he didn't take credit for any of them. He just would feed them out to people, and so it's like the electronic photography. He fed it out as a project, and it was super secret at the time. After I'd been working on it, and I went back to Lubbock, I had a security camera on my desk, looking at my desk and me all day, and it was watching all night to make sure that nobody touched my desk, because they might find something about the secret project. And and they would have brainstorming sessions. And in fact, I was on vacation with Reba and the kids out in San Diego, and I got a call on the phone and said, Monday morning, we need you in Dallas in a brainstorming session set up by Haggerty. Oh, it wasn't Haggerty then, it was probably, let's see, was it? May have been. Anyway, the research management people. And so we would sit around and do brainstorming of technologies that they had. They had a safe of things that had been developed that are super secret technology, and it was in the safe. Now, how might we use that? And of course, then you have the operating division that says, oh no, we can't introduce that, we'll lose customers. And that's the same thing that happened to Kodak. Is you got an operating division that's making good profit, and they're 2/3 of the company. You can't fight them, and was what semiconductors is. They're so hard to fight off.
Well, it's very understandable though in retrospect.
Oh yeah.
Because I mean, you're talking about you've got a workforce and they have families they depend on. I mean, it's you got to balance. You don't want to cannibalize
right.
your own.
You don't want to totally cannibalize it, and you don't want to cannibalize it first. But that's why you have to do it just right. And that's why you need someone, like Haggerty was good enough at doing things technically oriented and hand the stuff off. Other people aren't, and they make mistakes and they're late. And if you're late to market, you're late. And if you're early to market, you're too early. You got to look at the market. And if you're too early, and that's just something we found with the home computer. That's why we had, I think we had 5 different areas that we were going to work in. And some of those areas, like for instance, delivery of food, that you can sit here on your home computer and say, here's the food I want. And they'll deliver it to me. Well, it took the pandemic to let for people to do that. It's something that people used to do that. They pick up the phone, they call the grocery store and say, here's what I need. Guy puts it in his basket on his bicycle and he rides to your house. He takes it out and he gives it to you. And that era is gone, and so people don't like that anymore. They want to go to the grocery store. And so we thought, hey, no sweat. In fact, we had the vision that we can build an interface into the refrigerator so that every time you put something in the refrigerator, the computer recognizes, you take the list of stuff, your computer's got it all, and it updates what's in the refrigerator. So now all you have to do is go up and check the refrigerator, and it gives you the list of what you need, and you can email it to the store, and if you want to drive by and they put it in your trunk, fine. But nobody wanted to do that as a business until the pandemic.
Well, and actually, it's funny you mentioned that. I mean, that idea of something that's tracking internally what's inside the refrigerator. I mean, Amazon has retail stores they've opened where there's no cash register. You literally walk in, you grab whatever you want, and you walk out with it. It automatically detects what you took, and it automatically bills you for it. I mean, that type of idea is what they're doing today. So.
That's right. Well, it's taken a long time because, at the time we were doing the home computer in 1980, we had visions of that happening within, 10 years at least. 5 to 10 years, people will be able to penetrate that. Well, there's some of them that it took something like the pandemic or whatever, or a recession or a war. Those are 3 big events that change the way people operate. And so, but you don't know if that's the event that'll take, because other things like the iPhone, once it came out, everybody wanted one.
Well, it's interesting too what you said about that, because the notion that Apple would have been reluctant to release that, I mean, that makes a lot of sense, because you got to consider in that era, Apple themselves had released products like the Newton, the PDA.
Oh yeah.
So they were familiar with the basic concept of that type of portable device and the fact that it had failed.
That's right.
And you look at HP and Palm and a lot of those companies that had PDAs, which essentially are the same type of technology, just missing the cellular modem. Those technologies were really failing in the marketplace. So the skepticism actually wasn't unfounded.
No, you got to be partially skeptical. Look at they developed the Lisa thinking that was going to be, the best thing since sliced bread, and it was too expensive, just over the threshold. So then they came out with the Mac, which Jobs personally built. And what he did is he took the features that he was going to have in the Lisa. If he'd been left alone to do the Lisa, we might not even have Apple any. It would have been a total loss. But he built the Mac instead and put the key features in that he could without violating its cost, because they decided the Lisa didn't make it because it was too expensive. So you have a cost ceiling, but the features didn't require. The features were like the mouse. Well, the mouse can be put into a cheap computer, easy. So he could take those features that were in the Lisa, and they had bought from Xerox. Now, a lot of people think that Xerox just really blew it, but Xerox discovered that they really didn't have the capability to be a winner in the computer market. They had bought SDS, Software Systems Incorporated, in San Diego, which is the company that Semiconductor wanted to buy their computer. But they had bought that thinking that all they now to do is research new technology in the research lab and then be successful. Well, they weren't ready to, with the right stuff, to know how to apply it to create success. And so they made what I consider a smart move, is they went and said, we know how to do printers, we'll just own printer business. Right. And they still do. I mean, what office can you go into that doesn't have a Xerox printer in it?
I mean,
You know,
they practically invented the category in a lot of ways.
right. You know, they got the patent on that allowed them to be able to create the printing at speed, but other people are in the printing business, but they just can't touch Xerox.
Right.
You know, Canon can make a desktop, and Hewlett Packard makes a really good printers, but they aren't. You know, Xerox is there, and there's no way they're going to get Canon, get the Hewlett Packard in the office. So Hewlett Packard is happy with, and Xerox doesn't want to make a printer just to fit on your computer, because it would just dilute their business.
Sure.
So they're smarter enough to know that that's not their target market.
Right. Kind of knowing your limitations is
Right.
a big part. Right.
But you got to know when you got to change too. And that's a tough business, because very few companies identify correctly the right time to change and go ahead and take their lumps, and you see things go down, the stock drops in half, and everybody is woe begone, we're in trouble, and then you build back with the new stuff.
Right.
And now you're double where you were
Right.
before you took that 50% dip.
Yeah.
It's something you need to do carefully, but you need to get the timing right.
Right.
If you wait too long, the opportunity, somebody else has already capitalized on the opportunity, and now you got an uphill battle to try to get back in the game.
Right.
And if you go in too early, then what you are trying to peddle doesn't fly.
Right.
That's the reason why we had 5 different areas in the home computer, that we can lose any one and hardly even notice that we've lost anything.
What do you mean by 5 areas?
I mean, you can go after the educational area, you can go after the security area, you can go after the essentially clerical area, or you can go after the entertainment area.
So different market segments.
And each of those areas is a separate market.
Yeah.
And if you go after any one, there's some of them, they're good markets, but they're not going to be available, or they require the right impetus to make it happen. And you can't be 100% sure. I don't care how good you are at predicting the future, you can't be absolutely certain that this is the way to go. So you need to be prepared to take an alternative. I mean, when they built the Edsel, they thought that they knew where the market was going. Before they built it takes a while to get a car out, but before they built the Edsel, you had people wanting better and fancier cars. And so this creates a vehicle that has a volume that's almost at the consumer level. It's a full consumer level volume, but it has features that make it look like a Cadillac. And so, of course, that's the brilliance that General Motors have, is to have the Chevrolet market, the Buick Oldsmobile Pontiac market, and then the Cadillac. And what they used to claim is that the bearing that goes in the car is identical, a Cadillac, but the bearing that goes in a Cadillac is made by a master mechanic, so that you know it's perfect. The bearing that goes into a Buick Oldsmobile Pontiac is made by a journeyman. The bearing that goes into a Chevrolet is made by a apprentice. So that it's the same bearing, and you might get a bearing that's of the quality that would go in a Cadillac. In fact, the chances are pretty good you will. In fact, using that as a marketing strategy lets people think that, well, I'm getting the type of equipment that's built for a Cadillac. And if it doesn't meet that level of specifications, then it's just a dud. And, 1 out of 20 or 1 out of 50, I don't know what would you tolerate for a dud in a car?
Right.
1 out of 100? 1 out of 100, I wouldn't even think twice. I would, if there's a possibility the car might be a dud and it was only a 1% chance, big deal. I mean, if it's a dud, I'll just take my lumps. But if it was 1 out of 3,
No, right.
forget it.
Yeah, 33%, much different equation with that. Knowing that you're involved in education, even still today, what do you think your career would have been like if you were starting today?
Well, from an educational point of view, from the day I left the university, went to TI, I taught a course at University of Houston because there was a lot of material that I had learned, a lot of stuff I learned working at ARL, and particularly a lot of stuff I learned working at TI that wasn't in the textbooks necessarily. And so there was an opportunity, and I would teach at night school at the University of Houston. And so I would just, after work, I would zip over there 3 times a week and go teach a night school course. And then after I left Houston, I taught at the University of Missouri and was there 8 years as a professor. But I had a mix of research and teaching. And sometimes I would teach an extra course just so I could use the research money to hire more students and do more research. Because in most of the courses I taught, as far as my methodology of teaching is, I usually never used a textbook. Because usually I taught courses that were either advanced or otherwise. I taught a course in engineering management, but I taught techniques and methods and knowledge that you needed about managing. I was trying to teach people how to become a project engineer. And so and there wasn't a good textbook to use. The textbooks came out of industrial engineering and had a lot of good stuff. And you can get those books, to teach you about PERT diagrams and all that kind of good stuff. And that was all well and good. But the methodology of how you run a project and what's important. And for instance, one of the things that I would try, the hardest thing to teach actually, is that if you're a project engineer and you put together a project that you're getting ready to do, if you need to do a design review really early. Now, most people would like to see that first design review perfect. You walk in, you show everybody what you were doing, everybody nods their head, and you go out, everybody's happy. You waited way too long, because when you go in, there's a possibility that there's something that you didn't think about or didn't know about that will change significantly the project. And if you wait until the project's done, it's either too late or too costly, or it's just, so you need to go in, and people don't like to be criticized, but you need to go in. If you aren't criticized, you didn't do a proper project review, because you ought to go in so that it's rough enough that someone's going to find a flaw in it or ask you a question that you don't know the answer to.
Right.
And you might think that's embarrassing, but it's better to have a working project and getting it out on time than it is to have a slight embarrassment by not being perfect when you had the review. And so that's one of the key things I tried to teach students. I'm not sure that you can ever fully teach all your students to do that. But they really need to, because that is one of the most important things for a project engineer. Anyway, I would teach some of the courses. Just to spread out the courses, I would teach a course over in Kansas City to University of Missouri, Kansas City. And once it would be one night. So you go over and you have 3 hours with these students that have been working at work all day. So I would teach them new material in the first hour. I would never give them new material in the second hour. The second hour, I would go over homework, which you could maintain their interest because they had homework that you were looking at and you could identify what was wrong with it or how it ought to work or so forth. So I always had it split, and then I'd always have a break between those two halves. And when I was at Lubbock, I was busy. I mean, we were really busy, but I didn't forego teaching. I went over there were two of us. There was a manager of software who has since died, and myself, responsible for the architecture. Not just hardware per se. I have other people doing hardware, some of the details. So I was really working architecture. But the two of us would teach a computer course at 7 o'clock in the morning before we started to work. And if I was on trips, because you have to do a lot of traveling, he would teach. And if he was on trips, because you have to do a lot of travel with software, I would teach. And so we had the hardware and the software parts so that either one of us could substitute for the other person and maintain a flow of a course that was half hardware, half software.
Sure.
And that worked great.
I know you've been retired now for a bit, except you are still doing teaching, I believe. But
yeah, I'm not doing any teaching at all now.
Oh, okay.
I've finally reached a point that I just don't. One of the things is everybody uses electronic media with showing, and so you go in with a handful of foils, and so you have to do a lot of prep time. And what I like to do is I'll have something like this. That's I walk into class with nothing more than that. An outline of the items that I want to talk about. And so I had a different style than using the modern technology that they have in rooms today. And so it requires a lot more work. See, I could do a lot of research and other things because I didn't have to do as much work preparing for teaching. Because I knew the material, and all I have to do is to make sure I don't forget that and so this tells me not to forget it. But the way it's being presented and the presentation techniques now are good enough that this way of working is not really good methodology of teaching in today's environment. In the last 10, 15 years, it's moved to where I would need to change the way I do things. I would need to get better at being able to prepare. You know, some people can prepare a presentation foil in a couple of minutes. Me, I'm slightly dyslexic. That means I type very, very slowly. I'm just reaching the point that now you can enter data by voice. Sometimes the voice recognition systems mess up what you told it. But that's a small amount of correction you have to do. But I can produce probably 10 times as much material in a period of time with voice entry as I do with finger entry. Right. Because if you hit your right hand finger when it should have been your left hand finger because you're slightly dyslexic, it really messes things up. Right. And so when I took typing, and I barely passed typing, put it that way. I think I got up to barely over 30 words a minute with 3 errors. That was good enough to pass. I don't remember whether I ended up with a C or a B, but it was probably a C because I couldn't get it any better than that. I couldn't type a page of information without an error.
Right.
Just couldn't do it. And I couldn't type any faster than about 30 words a minute, or everything was just garbled.
Well, the reason I asked about the teaching, though, is about in your retired phase of life now. I mean, do you still do any projects or design work? I mean, do you approach any of this like a hobby now?
Well, right now, there's one of the guys that's retired from TI up in Dallas, and my son and I are writing a book. And like most things that we were doing, he was interested in this, and I've been working with him on it. We started out assuming that the design centers that the government has all over the every major city's got a center to help people that are starting businesses. And we could present seminars with some of the information and stuff about project engineering that I used to teach at Missouri and other stuff. And so we could teach them some good material. The problem is they have on their staff part-time people that are retired that would have to be fired because they don't have any money. You know, they have a certain amount of money, and they have people that work with whoever comes in. And those people, and that's all the money they have. So they don't have any money to pay us.
Right.
And so we finally figured out that we could write pamphlets, our material, our books, but we can't, if we raise the price a little bit, they don't have any money to buy them.
Right.
So we finally decided that we were going to put together a book, and we have on how you take an idea and make it into a business, because there's a whole flow in how that can happen. And so we're trying to write a book, or we have written the book, and it's being edited for English and content, and make all the font the same. In other words, with three of us, we have 3 different types of font that are used.
Yeah.
So we have it being all glued together as we speak. It's been going on, and I'll have a meeting Sunday, a Zoom meeting, to discuss where we're going with the book. And so I am doing that right now.
Sure. But do you still do any electronics work? Or
No.
mostly?
No. And in fact, you know, my interest is hands-on electronics. Some people just love that and do it really well. That's something that I have always had people that they can do it. And so when I was doing it up at Missouri as a professor, I didn't do any of that work. I had students that do it. I would have my group, I'd have undergraduate students that worked part-time as technicians. In fact, I had students, and if they were good at ordering things, then I wouldn't even order parts. I would let them handle it all.
Right.
You know, they do a good job. So all I had to do is to see whether what they were doing ought to be tweaked a little bit. And then if they had some problems that needed to be worked on, I could point them in a direction that some of these problems can then become something that they can use for a thesis.
Right.
And so I would point them in the right direction so that this person could go get that thesis, another person could get this thesis, and another person could get that thesis. So I ended up with, I think 15 students that finished their PhD working in my projects. And the last one graduated just the year that I came to work for TI from Missouri. And so one of the reasons why I agreed to not just be gone for 1 year to launch the project, but not to complete anything, you know, just to get the earliest phases launched. So we got it approved by corporate, and everything was ready to go, and we had a plan of what we were going to do. and then I go back to Missouri and teach, all my students were gone, every last one of them. Then I would be starting from scratch. I would be going up there, I had over $1 million worth of research money, but these research contracts, I had one with the Navy, one with the Electric Power Research Institute, one with NSF, and one from Consolidated Edison in New York. So I had 4 projects that were feeding money, and so while I was gone for a year, all those projects were essentially emptied. They were being completed. In fact, I was still on the Navy project, so they didn't have to change managers, but they just put me in for 10%. So 10% of my salary came from the Navy. And that way I didn't have to try to get them to accept one of the other people at Missouri to be the manager for the project. The project that we were working on for the Navy was the ELF, extremely low frequency communication, to communicate to submarines that were submerged. And so it was a really very interesting, fascinating project. In fact, what they did is they had us evaluate they had 3 major companies, and they were writing proposals, and then a team of us had to be the ones that could be cleared for security clearances. So I had a couple of the students and a couple of the faculty, I think 3 of the faculty and a couple of students that got their security clearances. And I had a secret safe in my office, and the security people would come by twice a night and check to make sure it wasn't broken into, and all that kind of good stuff. And then we were supposed to write an evaluation of the proposals. And they had quarterly meetings, so we would have to go to 3 different places 4 times a year. So I had 12 trips a year where I personally had to be there, along with 2 of my other cohorts. And then we would evaluate the various companies. This project was really slow, long-going project. If I'd been in the Navy working that project, one guy was saying that his whole career with the Navy Bureau, I think it was part of the Bureau of Ships, he started working on that project when he entered, and he will retire while working on that same project for his whole career. It's kind of like some people at NASA, that their whole career is, a space program. But you have these really, really long programs, and that program was a really, really long program with the Russians trying to scuttle it. And that's part of, they decided that instead of doing what they were planning to have us simulate the communication system, because it needed some sophisticated simulation. But then they had problems that they let us work on. One of them was that the antennas that were buried in the ground would heat the ground up so hot that it would kill off the earthworms that were used for the fishing industry in Wisconsin. I mean, they have crazy ideas like that. So in December, we had to go up there. It was 30 below zero, and I had to dress up as warm as I could. At 30 below zero, I had to hike a mile through the snow to make a measurement of the temperature of the antenna when it was operating, and also a week later make a measurement of the temperature when it's not operating. We actually made the measurement when it's not operating first, and then you make a measurement when it was operating. And I had to carry a digital voltmeter in a backpack hiking through the snow. But I mean, some of the professors wouldn't do that. You know, this is what I want to work on, this is it. You know, what I like to do is if someone's got a problem and I can help, I'll work on it.
It seems like you've always had a very applied and practical bent or approach to
Right.
what you do. Yeah. In hindsight now, looking back at your career, is there what do you think your lasting contribution is? Is there maybe a technology or say a product or something that you think has changed the world, even in a small way? I mean, of course, having a PhD, I mean, you've added to the body of knowledge of the world in a dissertation, but, you know.
No, I think, you know, I have, particularly, you know, I've got 15 students that got their PhD and have gone out, you know, a couple of them, I think 3 of them went to work for Hewlett-Packard, and they're out there doing high-tech things. Some of them have gone off and formed their own little company, and I like to think that I have taught a fair number of students some of the technology that's just slightly beyond what they would get straight out of the textbook, so that when they go out, they're one step ahead. I mean, they quickly start learning. You know, you find out when you get out of school, there's things are a lot different out there. Now, I had one advantage that, you know, having worked through the analog computer stuff and then worked at DRL, it was a lot like, I mean, I had to build equipment that had to work. You know, I had things that you had to do. I had to build, I built a lot of hardware filters that were being used for, you know, the research technology there. And so I had that advantage that most people coming out with their degree don't have. And then when I went to TI, I was thrown into the swimming pool, whether I could swim or not, because they, you know, I had the opportunity to make a suggestion. You know, I was just at the right place at the right time. If I'd gone there 1 year earlier, I would have done some work. You know, they wouldn't have thrown, you know, what they were looking for was something new beyond where they were going, and they gave me that opportunity.
Right.
Rather than, here's something, we know what needs to be done, we need somebody to do it now. There's a big difference there.
That's right.
You know, there's if you're thrown with the requirement to figure out what needs to be done and then do it, is different from we know what needs to be done, you're the new man, we want you to be the part of the team, and here's the team. Right. Rather than hey, we want you to figure out what needs to be done, now we want you to do it. Right. You know, so being at the right place at the right time. I mean, 6 months earlier or 6 months later, and that first project wouldn't have been mine. Right. I would have been part of defining what needs to be done, and I might have done the mini computers, because one of the things to go along with, you know, my boss was always keeping a lot of different channels open. He said he wanted me to look at, Digital Equipment Corporation had a PDP-5. It had 8 instructions. That's all the computer had. It was a new computer they were working on, and they didn't put it into production. But he said, I want you to look at what they're doing and see what we need to do that might be interesting. That's at the very, very small level. I mean, this has nothing to do with seismic processing. You know, it's just, he wanted me to be looking at that while I was looking at the other part. In other words, think about this other thing too. And so that's where we were ready to go build a computer that was not a seismic computer and get it done in a year. And so I was at the right place at the right time. And I can't say that if I'd been a little later, things might have evolved to where I was going. But, you know, I ended up going to Missouri at just the right time when the group that I had up there was the Digital Power Systems group, because the computer people considered it beneath their dignity to work with the power people. Power people were like, you know, those aren't high-tech people.
Right.
You know, the power companies, in fact, even considered that, you know, if you're not interested in power and going to do that, I was looking to see if I could get a scholarship down at A&I when I was getting out of high school. I went down and talked to them, took an exam, and I think I did okay on the exam because I had the same exam up at when I went to UT, and I think I had a 100% score on it. It was an engineering type exam, and so then when I was leaving, I said, I want to be a communications engineer. And they said, we're not interested in communications engineering here. We want power, we pay money. We won't give you a scholarship for communications. We'll give you a scholarship if you want to work on power.
Right.
I said, forget it. I'm going someplace else.
Right.
And I did. But that's, you know, if I've been fortunate to just be at the right place at the right time. You know, I was right there, and I had the group of people and everything so that we could jump right on the Navy project when they came by looking for somebody to work on it, on the ELF stuff. If I didn't have some of the military guys, I wouldn't have gotten the security clearances in time to, you know, do some of the work. But I had the military guys that, you know, already had their clearances. And so all we had to do was to get a safe. We drove over and found a safe that they were throwing away in Kansas City, which has, I think, 8 inches of concrete around it. I was surprised. We could barely get it up into my office.
Sure. I bet. Wow. In your background, when you talked about like the ARRL book, are you a ham radio operator, or did you ever become one?
I got a novice license, and then I got so busy with school that I didn't. The other problem I had was getting my code speed up to was it 15 words a minute. You know, I could handle novice speeds. But at that time, if you wanted a general class license, you needed to do the 15 words a minute. And I just couldn't hack that. And now I'm pretty sure I know it's because I'm slightly dyslexic, makes it more.
Well, they don't require code anymore, so you could be an extra now if you wanted to be.
Right. Yeah, that's what I understand.
I just asked because I mean I'm a ham radio operator.
Oh, okay.
Myself, and, but it's interesting that.
Yeah, I was KN5 DQP.
Oh. I mean it's a common theme though. I mean, you know, not only people I know personally, but when I talk to people professionally and how they got into electronics, ham radio really is a gateway drug to the electronics world. I mean,
Oh yeah. And those books I got, the Amateur Radio Handbook,
yeah.
you know, that's about that thick. You probably have a
It's
copy.
still published, yeah. They come out with a new one every year.
Yeah.
I've got a bookshelf filled with them. So.
Yeah. And you learn a lot of stuff just reading that book.
Yeah.
You learn what a superheterodyne is and all that kind of good stuff.
Right. So What's your opinion on the landscape of, say, electrical engineering today, and how people would get into it?
There are, I don't know how many subfields, but there are like a dozen different subfields now in the, I'm a member of the IEEE.
Sure.
In fact, I was originally a member of the IRE,
Right.
and then they merged the IRE and the AIEE. Those two organizations merged and became the IEEE. And the IEEE now has at least 10 subfields. They have, the one I published in or was working with was circuits. And so they have the circuits, they have AI, they have, every different subfield. They have solid state technology, and so they have a broad range of things. And so the thing that's a little regrettable is that most of the schools now have minimized, almost eliminated electronics. I had to fight hard to keep the electronics. And when they updated the curriculum, you got these people that say, oh, we need to put waves and fields in there. You got to know about fields. If you don't know about fields, that's a big part of what everything is doing. All of these different communication systems and stuff. And of course, the fields requires, you got to know Maxwell's equations and do stuff, it's high level mathematics. And so I'm sure you're not at all interested in that. You'd be interested in the electronics part of it, except most of the curricula is not doing that anymore. And you only find, I don't know where, we kept it alive up in Missouri, but only with a lot of work to keep, where you had 3 electronics courses, it went down to 2, but you kept at least 1 electronics course in there. And, of course, power systems has kind of got pushed out. When I went to school, Double E required 146 hours. And you had to take courses in both courses, including labs, in DC machinery, 2 courses in AC machinery with 2 labs, 2 different labs. So you got all of that amount. And they took about, they had engineering economy you were supposed to take, but if you took your electronics course 1 semester early, you could take communications engineering, and if you took communications engineering, you then could substitute the course in high frequency stuff if you, instead of engineering economy, which I did, and that was good because since I didn't take engineering economy, and the chairman of the department was taught that course, that was his favorite course, when I went in to get a job grading, because I needed money, he looked up and says, oh, you haven't had engineering economy, have you? I don't believe we need you as a grader.
Oh.
And when I complained to my lab instructor, he said, oh, you ought to drop over to Applied Research Lab. They need some people. And I'd had 3 courses under this guy, and he worked over there part-time too. And so I went over and got hired. And so just because I hadn't taken engineering economy, so being at the right place at the right time, it's just a matter of the cards, the way they fell were just right. And things kind of flattened out when I went to Dallas. It was, I never could get anything that I could fully get my teeth into. The military goes way too slow. I did almost managed to make a few changes. I at least got them to think twice. You know, the gallium arsenide people actually built a processor, and I've got a chip that shows it's the MIPS Incorporated made a high performance processor, and we thought that that's the signal processor that the military ought to be using, and if they used gallium arsenide, it was rad hardened and it could do their high performance computing. So I tried to push that for them, but the politics just, you know, TI didn't have enough clout with Lockheed and Boeing and McDonnell Douglas. I took one trip. I think I went to 10 different places in 1 week. Flew from coast to coast, and you know, as I say, I went to the Bay Area, I went to the LA area, I went to St. Louis, I went to Atlanta, I went to Florida, and I went up to Washington, and I went up to New Hampshire, to all the military locations to try to sell them on it. Right. And the Intel got selected, and then Intel comes out with their processor. You know, TI makes to demonstrate. They had two of their vice presidents and TI's vice presidents there, and I was at the meeting, and they were displaying how they were going to do the signal processing. And I knew what processor they were using, and I knew how much power it took, and the amount of power for they had to use at least 2 processors, if not 4, on a board, and 2 processors exceeded the power that could be handled by the board that the system did. And so I knew that. And so I said, wait a minute. It takes such power, you can't power the system. Their vice presidents just packed up their stuff and they went home. But still didn't give it TI. You know, the company went ahead with Intel. They selected the Intel processor, and then Intel decided they weren't going to make it anymore.
After all that.
Because they were what they wanted was to get a processor to get the volume business to compete with TI's signal processor. Right. TI has the a whole line of signal processors that they've still manufacture.
Right. DSP has been one.
DSPs, right. And so since they couldn't get a commercial business, the military business didn't have enough volume. And so they said, we're not going to make it. When the first time, then we were going to make the semiconductor asked about, and I helped them work on a cruise control, automatic cruise control. It used a homodyne gallium arsenide 60 gigahertz transmitter, plastic that's coated with a metal coating for the antenna, is something that the military group developed. And so you could make a very inexpensive, using the TI signal processor, you could receive the data and process it, and so you could transmit, but the distance was short enough so that it only looked like 50 yards ahead of you. Otherwise it died out. At 60 gigahertz is one of the attenuation windows for the atmosphere. And so we had the whole thing designed. The president of Chevrolet said, guaranteed, we said, before we proceed with the project, we want to make sure you're really going to do it. He said he would guarantee that they were going to do that. They were going to use it. And the president of General Motors overrode him and said, we bought Hughes Aircraft to build signal processing equipment, and we aren't going to pay TI to build that kind of stuff. And they went to Hughes, and Hughes said, can't be done. You can't make that. We knew how to make it. We had the design and everything else. And they just cut it off. And, car companies are that. They, particularly at that time, ruled the roost. And you couldn't say anything. You couldn't argue with them, But we just got cut off at the knees. We were almost, we had the design figured out how was it going to make it work. But it took another 15 years before automated cruise controls ended up, and I'm not sure which scheme. I think they probably use acoustic, I'm not sure, or visual. There's such good camera stuff nowadays that they're probably using that. For a while,
it is either visual or,
yeah,
or LiDAR.
Yeah. Some of them, one of the things that Xerox developed was that little acoustic disc that they use for a rangefinder for the Polaroid cameras. Mm-hmm. And those discs are all over the place. They used to use them in cars. Part of the things that would buzz when you got too close to the curb, that little rangefinder works really great. But it's not really as perfect as, you got so many ways that you can do things. I run into a lot of people that have, when I was teaching a night course down at Texas State, one of the faculty members there said, oh yeah, she had one as a girl.
So who were some of the other team members you worked with?
Oh, Herman Harrison was a software developer. Let's see, Bill Nail. I'm really getting fuzzy on remembering names. I still remember a lot of the technology stuff pretty well, but the names of people have always been. We've always had a pretty tight little group, and down in Houston, Lynn Donahoe was key as a manager in Houston and on the stuff in Lubbock, but the other people that we were working with, let's see, Herman Schwerman, one of the people, and then there was Herman, Herman Harrison was the software manager. Gene France was did the Speak and Spell, and he was kind of off in a different group, but we worked closely with him, and he folded into our group that was eventually dispersed. And he became a TI principal fellow. Went from SMT. I think we had a group of about 10 of us. I think 5 were job grade 32 senior members of the technical staff that were in Lubbock. One of them, let's see, Dave Stevens was one of the guys. He's the student that was in the Air Force that I had, and he just died. Let's see, anybody else? I mentioned Nail. I can't think of our. We had a linguist. Had her husband was a patent attorney. He was our patent attorney, and she did the linguistic for the speech. See, we took the nodule out of the speak and spell and modified it so that it fit as a attachment. Here's
Right.
speech module.
Sidecar, right?
Yeah, and so we did. She had developed the allophonic speech using, instead of just phonemes, you had the front end, the middle, and the back end. So and each of those elements was an allophone. So you end up with like 3 times as many elemental sounds. And when you do that, instead of having the speech sound like the Swedish speech that someone up in Ames, was it? One of the professors up there had developed a speech technology that had this very Swedish accent. We had, a more natural speech. Of course, the speak and spell used real speech and coded it, and then put it into the plug-in modules for the spelling. And of course, the development of that. Larry Branningham was he liked that. He suggested the speak and spell as a product. Anyway, Larry Branningham is, he and Gene France and Paul Breedlove were involved in development of the speak and spell as a product, and he actually did the whole design for the speech chip. He would do it. He would do the diagrams for the layout of the chip at a washateria at night while he was washing his kids' clothes. Sure. And carried it crew under the eyes and management control and so forth of Gene France and Paul Breedlove. They were in a different branch in the calculator group, the total calculator group, but they then had the educational products, and then we had the computers. And here's another version that we had for low cost. This is a 2.
Oh, that's an actual 992.
Yeah.
Okay. I've heard of the existence of that unit, but I've never seen one.
Yeah, there it is. And that and the CC40, they all came out of their design group because whenever they had any spare time, they, and the engineers wanted a computer that was theirs, and this is one that they came up with and did all the stuff on it. And that's kind of when I was off fixing the video system for Haggerty's project.
Is that 992 functional?
As far as I know.
Yeah.
I don't know what I need to do to plug it in. Here's the 52, and here's the, that's the one that has a little card reader that you can stick in. That has data on it that'll run. This one, the back thing is missing. This is a SR50.
Oh, okay. What about the accessories? Were all the accessories like the peripheral expansion box, was all of that also designed out of your group?
Oh yeah.
Oh, okay.
Yeah, we had that great big box and had all those cards that plugged into it and the whole works. I didn't spend a lot. Most of that was a matter of doing good mechanical and putting the components together and laying the circuit boards out, but not any new, different architectural change. It just added new features or became a bigger combined unit, or so there was a bunch of different things going on all at once, and I was getting thing. I was working, primarily on looking forward to the next generation, and I was looking for the, what kind of display technique that we could use. And of course, the LCD stuff, which finally blossomed and became, and just wiped out all of the regular TV sets once it reached that capability, and starting where this is the state of the art of LCD, and you've got a little bias control on the side that you have to adjust to get the brightness just right, because it depends on what the room temperature is. And Milton Bradley had a brilliant idea. They had the Connect 4 toy, which was a Hangman toy that they had the LCD screen. And of course, you had to have the control, and they considered, hey, people just aren't going to like that. So what they finally did is they had they put a label on the control that controls the bias, and called it the contrast control. Every TV had a contrast control, and because of aging and other things, you had to adjust your contrast control on your TV and your color balance control. Those two controls on the back of every old TV, if you remember those days. And so calling it a contrast control, everybody accepted it. It's natural. No, this has got a contrast. That's a feature, not a problem. Right. If you called it a bias, it was a problem. If you call it a contrast control, it's a feature.
Right. Yeah. Well, contrast also seems like a much more natural term, or at least the inference you get.
That's right. It's a good positive term, and so that was a brilliant idea what they did there, and but we had all these things going different. Whenever some of the engineers were freed up, then we looked at some slightly alternate products that we can have a array of products coming out.
Whole ecosystem of
which all came out of the product area. Something like this doesn't go into the department stores. It goes into the bookstores for the campuses and to the office supply stores. And of course, nowadays everything would be on the web and mail order, all that kind of good stuff. But we had a lot of stuff going.
With the peripheral expansion box, so you're saying that was always planned from the start to have that separate unit for expansion, or was that kind of done after the main 99.4?
It was probably, it was done later. It was, the problem was we had that expansion bus on the side of the machine. And we had the little boxes that go into the expansion bus, and they were designed so that you have a pass along. Like this one's the same way. It's got a window so that you plug this into the bus, you can plug something else in here, and this gets mechanically unwieldy. To you go out and get your kitchen table and have these things lined up across. So the idea was to try to find a way to put all this stuff together. Well, one of them was to have the expansion box and to put the peripherals in plug-in slots that doesn't look like a Rube Goldberg hodgepodge. And so that's where that migrated to. And because there were a lot of non-home interest in the product, a lot of people using it as a inexpensive personal computer. Yeah, and so it didn't necessarily have to be color, and it could have a desk, or so that the expansion box, so it could fit on the desk. And so it, I got to, or was given the opportunity to deliver one of the table and the full expansion box and everything that we had to the Eric Johnson, the founder of TI. He started in GSI and worked with Haggerty and founded the company. But I delivered that to his office in the building there in downtown Dallas, the bank building, the big, tall, multi-story bank building. They, just in case anything might go wrong, they said, you can deliver it, take the whole thing.
Send the engineer with it, huh?
Send an engineer with it. And then one of the board members was the president of the university in New York City, of the Rockefeller Institute, which I don't know if you're familiar with Rockefeller Institute, but it's in Manhattan. And they had, like, on their staff, 5 Nobel laureates. And all of the faculty got housing in Manhattan adjacent to the campus, provided as part of their job description. And it's an interesting, very, anyway, he is on the TI board, and I personally delivered him a full-up unit, complete with desk, everything. Went there and put it all in a taxi and went out to Manhattan and unloaded it and fired it up.
Yeah, the reason I asked about it is because, when you compare it to, so for example, the TRS-80 Model 1, they also came out later with an expansion unit. And the TI-99 unit, feels almost overbuilt. It feels much more industrial and, almost like it's built to be a tank, as where, Radio Shack's was plastic and, not very modular, as where the TI unit almost seems like a piece of scientific instrumentation equipment.
Right, yeah.
It just, it was striking, the distinction when you've got this, home computer, which especially in the later era when it went to the plastic casing and everything, has very much the feel of a consumer type computer product. And then you got this industrial, heavy steel expansion box. It was a funny contrast.
Yeah, well, that was going after a market that can afford more, so that you don't have the really, really tight price boundaries that you did with the 4 itself. And at some point we might have had a industrial version of computer that we would put on in its place. That wasn't a super high priority, but there was an opportunity window. The Houston folks, the Austin guys that were selling the mini computers didn't want to. We wanted to, the fact that they were making the 980, a 960, which was a military design that came down, a cut down version of it called the 990, that was designed as a reservation system for a motel, and then they productized it because it was cheap. And the reason they made the 9900 was because it had been cut down to the bare bones that they could, and they wanted to take the machine that we had in Austin, not the 860, but the 980, the 24-bit machine, and see whether they can put it on a chip. And it was just not even close at the time. But they came down from Dallas to start that in the research lab, and I'm sure same thing they did to Houston. They went down and said, what's the simplest thing that you can have that we can put it on a chip? And that's how the 9900 came about. But that was coming out of the directions by Haggerty, and not what semiconductor really wanted to do. They didn't think there was a market for that kind of stuff.
There was a little bit of complication that occurred during the design of the 99-4, in that originally you were supposed to use a different CPU than the one you ended up using.
Oh yeah, we were going to use an 8-bit CPU, and we were going to pick one. We were offered the 6502 for $1 a chip.
Oh.
They would sell it. They said they would sell us 1 million 6502s for $1 a chip.
And TI was actually open to that?
No,
Oh, okay.
we were told that we could not do that. They would not allow us to do that.
So you're saying you had designed the 8-bit architecture of the machine with the idea being that maybe the 6502 would have been the chip, and then you had to adapt to the...
Right, exactly.
Oh, okay.
I had designed, the whole design was original for an 8-bit chip. And I really wasn't that interested in the 8080. The 6502 ran circles around it. And of course that's what the Apple used. And there was nothing wrong with us using the same thing because we weren't going after the same market. And so that would have been a good thing. Now, Lynn wasn't going to buy the 1 million chips. He says, how about the second million? And the reason they were selling that is that's the chip that was available to run the games coming out of Hong Kong. And they had 1 million in the warehouse. And like games, the volume goes like skyrockets, and then it goes down to about 10%. And they ended up trying to make sure they had enough to supply the demand, and ended up with an excess of 1 million chips, and said that they would give it to us. But I looked at the you know, it's a pretty bare bones chip. I think I counted 1,000 transistors in it.
The 6502.
Yeah.
Well, why did TI never consider making a copy or a clone of it, or you know, in other words, it seems like you were aware of the 6502 and its capabilities and how it was having market success. So did TI ever consider making their kind of version of it? Or?
No. Well, the problem is when you know, TI was really straight-laced in the way they operated, and they didn't. They might look at and to the nth degree of everything anybody did to make sure they knew, but they were not going to sell product which was which violated somebody's intellectual rights. And if you can't negotiate, now they might have tried to negotiate if they got interested in it, from, you know, semiconductor division got interested in it, and negotiate. And what you typically try to do is to have a chip that the other company wants bad enough, and you will trade intellectual property for that chip that you want in a trade between the two deals. And there's a lot of that goes on. But without getting rights one way or another to the intellectual property, TI would not touch anything. They would not duplicate a chip that way.
Oh, well, I'm sorry. I didn't quite mean duplicate. I mean, certainly TI had the expertise where they could have made an 8-bit chip of their own design. It seems like pretty easily. I mean, if you already had a calculator division that's making. You know,
oh yeah,
it's
to get right in the middle of the CPU race. You'd have to ask the semiconductor people their thoughts about that, because it would be a division. One of the things that TI Semiconductor, I'm sure, was making their decisions on is that if you build a competitive chip, you have probably eliminated the 3 other companies buying your peripheral chips. You know, it just kind of goes that way. If you have a chip that's competing with them, so they would rather put their money on selling the peripheral chips as their business and avoid doing the head-to-head because it's like they had a device that would make a really nice microwave oven that they wouldn't put on the market because it would the microwave oven people wouldn't buy any TI chips if they did.
Yeah, it's more of a, you know, protecting the business relationships you had.
Right, exactly. And it's a carefully orchestrated, you know, at the high level. Dealing with IBM was always touchy,
Yeah.
because there was the constant threat that IBM would just buy the whole company.
Yeah.
And you know, so they, and I don't know what it was. I don't know the business well enough to know what some of the possible candidates, but I've been told that TI had a good poison pill in the system that would make them not want to buy TI, because otherwise, because the number one customer for TI products was IBM.
Right.
And the TI built a factory in Sherman strictly to get the TI personnel out of the TI plant in Dallas, because they would be snooping, and you can't take your best customer and tell him, no, you can't go down that aisle.
Right.
Or you can't go on that floor.
And right, with all the military group there. Yeah.
Well, not just that, but you know, do you know how TI really got how they got the big lead in the semiconductor business? You know, the semiconductor started out on germanium.
Right.
Germanium had the problem of thermal runaway. When it got a little hot, the leakage current just went up, skyrocketed, and it just burned up, go into thermal runaway. It was just, so you had to keep them cool and be very careful. And everybody knew that if you could just make it out of silicon, it would really be great. And to have silicon transistors. And nobody could figure out how to make silicon pure. They tried and tried and tried, and they couldn't get silicon pure enough to make, and if it's got a little bit of impurity, it's got leakage, and it, you know, it just doesn't make a usable device. And so TI figured out how to make pure silicon. And they were the only company in the world for at least 2, maybe 3 years that could make pure silicon. Now, when you have, you know, it's like being the only company in the world that can make gasoline, and you have all these cars driving with gasoline. And if you don't use gasoline, you got to use diesel fuel and diesel engines, and it's just, you know. So it was that equivalent, and so, and it was strictly a trade secret. There wasn't a patent. TI figured out how to do it, and what you had to do, the physicists had determined was impossible. It wouldn't improve anything, and there's no use doing it. But it's not a secret anymore. So what they did, you just saw the end of the bar off, you know, a few inches, and throw that away, or reprocess, or whatever you have to do, use it to grow more crystals, and then purify the bar, and it's better. And saw that off, purify the bar, and it's just a little better. And so, because you try milking the impurities to the end of the bar, see, is what you tried to do. And no, the milking process would not get it pure enough. But if you sawed that off, it then would purify. And you saw it off to it a couple times, I don't know how many times, suddenly you could make pure enough silicon. But they didn't tell anybody. And IBM used to come and watch them. They didn't saw it off at night. They probably did that in the middle of the night. So when they were watching. But they watched and they watched and they couldn't see. What are they doing? And they're getting pure silicon. And we've tried it and tried it and tried it, and it won't work. And they come back down and they look, and year after year, TI was the only company making pure silicon. Well, if you make pure silicon, then you can make silicon devices and sell them cheaper than anybody else in the world.
Right. Your yields are that much higher, right?
Oh yeah, I mean it handled the high temperatures, didn't have the leakage currents. It ran faster, and then you just got on that ramp, and eventually, people discovered, but TI was then the leading company in the semiconductor business.
Right.
And that's how they got there.
The home computer, it's much like many of its contemporaries. They all have little quirks. One of the interesting quirks to me, I never owned a 994A when I was growing up, but as an adult I bought one. And one of the things I noticed, there's no backspace key on it. Or why is that?
Oh, probably an oversight. Yeah, I hadn't even thought about that. We were going, hell to bent leather, but right down the road to as quick as we can. Herman Harrison was in charge of the software and the software group. We were looking at the software, and we were trying to decide what we needed to do. And we had heard that somebody that was I guess it was the Kim out in Albuquerque, was developing had a real neat way to develop software. Someone by the name of Bill Gates.
Or Bill Minch, right?
Bill Gates.
Oh, he was developing for the Kim?
Yeah.
Okay.
That's where he started. He developed the methodology when he and his roommate, let's see,
Paul Allen?
Yeah. The two of them dropped out of school. They heard all this stuff going on. There's stuff in the Bay Area, but they went down because the Kim, it was a kit computer, so that you take a nice fast computer. It didn't cost very much to buy it, but you had to have some software, and they really needed software. So they drove down to Albuquerque and said, we can develop a computer right away. Well, what he did is he broke the software for a compiler into two parts. One part created a pseudo language, and the other part created the instructions that executed on the computer. And if you wanted a different computer, all you did is took the instruction translator, and all of the compiler stuff was unchanged. Right. So it was a two-part process, and you could develop it in a month. Right. The whole thing. Go down there and bam, bam. A couple of months later, they had software, and he went to the Bay Area, and then on up to his mother was, I think, a bank vice president up in Washington, Seattle. And anyway, he got the IBM software. IBM desperately needed a disk operating system. And his mother was flying with the president of IBM from a fundraising event
Yeah, I read that she was a board member actually for IBM at the time, or
She may have been, or he got made one right after that. Anyway, they were flying back from a meeting, and he was grumbling that, oh, we just need an operating system desperately. We're going to have a computer. You know, they were building 3 separate locations, were building systems. And Florida had everything ready to go because they bought everything. They bought the Intel processor. IBM was building their own, but it wouldn't be ready for another year at least. It was in the research lab that they were building it in New York. And and she said, oh, my son does software. I think he can do something for you. And so he called them up and said, go talk to Gates. He can get you some software. And Gates flew down there and said, sure, we'll have it to you. And he took his magic software development. But we thought about using his system, but it wasn't fast enough, particularly with the 9900. I mean, it just, if you take and cripple, because you know when you do that 2-part stuff, it runs about 4 times slower.
Right. It's interpreted at that point.
Basically, it's interpretive. Yeah. It's an interpretive approach, and so we developed our own graphics language, and we wrote our own compiler all by ourselves.
So the GPL, right?
Yeah.
Yeah.
And we did the GPL, which some people called it Granville's programming language, but it's really graphics programming language. No, it was graphics programming language from the get-go. Because Herman and I taught that class over at Tech together, and I'm well aware of the development of it. And, you know, some people, jump to that conclusion, but the computer, we were admonished that we were not building a game, and we would never call it a games language, because that would immediately have what we were told not to do shoved in our face. What are you doing out there? So there was no way we were going to call it a games programming language. We were skating on thin ice by working with Milton Bradley as a games company. They wanted this to be a serious machine.
But did anyone, in retrospect, ever reevaluate that decision to maybe see some of its flaws? Because, for instance, you know, many of the companies, like Apple, for instance, I mean, through the 80s, one of the things that helped propel Apple and competitors to TI to great success was their embrace of gaming, in addition to business and commercial applications. I mean, it's interesting, that dichotomy, because, for instance, the Apple II, you know, there was a real concern at Apple with the Apple II that it would have been a failure and the company would have ceased to exist. It wasn't until you had things like VisiCalc coming out that all of a sudden a machine which was viewed more as a home or, you know, personal machine all of a sudden saw some serious business use. And likewise, you had other machines that were seen as, like the IBM PC. I mean, a lot of its big technological growth came when the gaming world started to, you know.
Well, yeah, and I can understand why. And the people in Houston were not at the meeting. Lynn and I made 3 presentations to the Corporate Development Committee. And they admonished us that you will not build a games machine. It will not be a games machine. It will not have anything that looks like a games machine. This is a serious product, and it can do games, and that's just one of its functions, not the primary one. And it may be a one, but it will not be a games machine. And so a lot of people, including a lot of our marketing people, once we got going, like particularly the guy that came from DEC, wasn't at that meeting and didn't always do what he was told. like changing the price and making it illegal and eliminating all computers from TI. So we were told with specific instructions that it is not a games machine. It can play games, but it's not a games machine. We do not want that image for TI. No matter what, or no matter how much money you can make on it, we do not want that image for TI. TI is a serious company.
If you were to ask the average person on the street today what they know about TI, they would say something like, you know, the TI-83, the graphics calculator, or, you know, or the Speak and Spell, right? I mean, these consumer products. I mean, that's largely...
those are fine. Those are fine. That's, you know, that's a serious image, and anything educational, business oriented, you know, and it can play games. You can play games, you know, because everybody plays games on all sorts of things if you can do it. But they just didn't want that to be pulled into that kind of an image, and so that was. But there were just a few of us that were really on top of that, and you know, once Lynn was gone, you know, it was, the barrier was completely gone. So as I say, it was a graphics programming language, and you know, we created the tokens to try to make it run fast, and unfortunately, you know, it's like people got hooked on the games stuff, and to be the best games, they had to do assembly language. Go down to assembly language, yeah. And if the original, by that time, of course, Haggerty had died, and it was just the whole crew operation of where you were going was not focused. You know, I was down in trying to implement rather than continuing at the high level of how you focus the product and where you take it and who you talk to, because, you know, Lynn had a good handle on that. But once he got stabbed in the back and then left, we lost that opportunity to do it, because what TI would like to have done is, you know, like Hockaday School in Dallas, they had a home computer on every desk in the whole room, just as an experiment to see if the students have. And so every student had a home computer because they could afford it, you know.
Sure.
So I don't know how many, 15 girls, 15 computer setups. Right. And so that was a great image. If the computer-driven software, maybe AI will really make that happen. I went up and visited at I guess University of Indiana was doing an experiment. They had a freshman course in biology that the students could do it at their own pace, and it was all computer oriented, but that it just didn't fly. When my student Dave Stevens went to the Air Force Academy, he and 2 other professors spent 1 whole year developing a freshman program in electronics, just to get enough so that you could have a computer one. And what computer-aided education has really struggled hard. People thought in the mid-70s that, boy, computers is just going to be replacing teachers.
Right.
And it's difficult to do, and it may be that AI will have enough features that eventually you can do that. The problem is there are different types of learners, and you've got to essentially adjust your material. In other words, you're making a presentation and you're looking at your class, and when you see their eyes glaze over, you make an adjustment somehow, one way or somehow another. Or you see one student who doesn't seem to be getting it, and then you find a different way to explain it so that the majority of the class does get it. And computers have never been able to do that level of adaptability, so that, you know, it's just not good enough to say, okay, you can do computer education and you get 50% of the class and they all do good, and the rest of them we'll just wash them out, forget about it. You know, we didn't need them to take that class anyway. Right. You know, they've got a diminished capability in that class. And then when they take the second course, they're going to have real problems. And the third course gets worse. And if they were all computer oriented and you were missing the way to teach them and get them the information, they're a lost soul. They drop out and get a different career. And so I think that at some point, I don't know how long it's going to take. It may be faster than I expect. But at some point, you're going to see that we now have reached the point that with AI and with the right instructions into the AI and with the adaptability built into the AI, you will actually be able to teach and have it better than just letting a person learn it out of a book at home.
Well, that is the opportunity, right? I mean, when we look at AI, the idea that, you know, the idea that you would have a system that's smart enough to do as good of a instructional job as a real human teacher, but still be adaptable. Because, you know, as a college teacher myself, I understand what you're saying, and that it's hard to tailor our approach to try to meet the mean of the entire class we're in front of. But the advantage with AI is that, you know, because it is so individual, the AI could adapt its approach to each student.
That's right, exactly. And I think that we're going to be able to start seeing some AI-driven education.
All right. Oh, we already are.
Yeah, oh sure. Yeah, and it's encouraging. I think that's going to be good. It probably won't be 100%.
Sure.
It's just like you still have a few secretaries, and you'll still have some people that take either the special needs or adaptation or somehow the ability to make your AI program so good that it doesn't need any help for anything is not likely. But it'll get better and better. But there's going to be opportunities to do better than it can do, and those aren't going to go away.
When y'all were developing the home computer line, did you do marketing research? Did y'all ever have focus groups or things like that where you would kind of, like, how did you develop the specification or the architectural idea of what the home computer was supposed to do?
We did make, you know, TI made use of focus groups for sure. They did them with the Speak and Spell. They did them with the the Little Professor and the other things. They did them with some of our calculators, and I think I was in a number of, you know, behind the mirror watching, because that's the way, you know, you have a small team that watches and if you've got a good company that is running the focus group, they do a really good job. They ask kind of open-ended little questions that leads the people of, oh, what do you think about that? What would you change? You know, what's the best feature that you see? You know, just feeling them out, and you know, they'll have typically, I guess, about 5 people. I don't know. Have you done a focus group? Mm-hmm. Yeah. So you know what I'm talking about, and it's a really, not doing that would be dumb.
But I mean, but when you started with the home computer project, was there any of that research that was kind of done for you or
No.
to you?
It was clean slate. All we did is we presented, as I say, we put together a chart foil presentation, presented it. They had some criticisms, and I don't remember what they all were, because this all was a quick type of thing. And we went back to the drawing board, put together another set of foils, and it was just me and Lynn that were making the presentation. He was really making the presentation, and I was there to assist him and answer any questions they might have, technical questions and stuff. And so we had to go back 3 times before we had a presentation of a concept that they would fly with. And then at that point, we were ready to get started. The idea for the Speak and Spell cropped up right in the middle, right about the time that we had the home computer as a going thing, and the Speak and Spell pulled Larry Brandingham off. And I was at the meeting, the initial meeting we discussed it, and then I did a design to cost estimate to see whether it could be done, and I gave it a positive, yeah, I think we can do that. It can be done. And then at that point we had the home computer to go and the Speak and Spell, and so he took the Speak and Spell essentially as a one-man show and did his thing with it. And then we built the hardware team, and I was supposed to be responsible for the total chip design group, to design the chipset and that we might need. And my boss in Dallas decided that he was going to go to Lubbock, and he was had a seniority, and he took that position, because that group did the designs for the calculators and for the home computer and for the Speak and Spell. All the products, you know, went through that one group. And so then I was made just in charge of the architecture, and which worked well. It was fine. Doing the chip design, I could have designed the architecture in that group, which is what Lynn had in mind initially, but then I could do the architecture and feed it to the people. And as it turns out, we weren't doing a bunch of custom chips ourselves anyway. You know, there was a possibility that we would have built a custom processor if we had the group that we were doing it that way. But since I didn't have the group, then the group was being run more for Speak and Spell and for all of those other products. And then the speech chip was, all we had to do is just do a minor modification the way it had its interface. Right. To have a speech chip that went on the speech module.
Well, I guess the reason I asked this question, because, you know, of course now 40 years later we can see a lot of common themes among computers of that late 70s era, right? I mean, everything from, you know, from the inclusion of BASIC as the programming language that most
Right.
of them came with in ROM, to the type, using TVs, consumer televisions as the main display. I mean, there's a lot of common themes we see now. But I'm wondering, the reason I asked this question about the design and kind of the market research is because being that, you grew up in an era where you didn't have computers commonly around you. So
Right.
if you're in charge of a team developing a home computer in the midst of this very dynamic industry at that moment in time, I mean, how would you yourself be familiar with the market requirements or what people were looking for? I guess I'm wondering, how did you know what to design, in essence? I mean, because it was very much open-ended right then. I mean, you knew it was going to have
That's
a
right.
keyboard, you knew it would have an expansion bus, I guess, but many things were not set in stone at that time. So.
Yeah, and we had some discussions. For instance, initially Lynn didn't see that we needed a QWERTY keyboard, and I finally told him that there was just no way we were going to build that kind of a machine and not have a QWERTY keyboard.
Well,
because
what does that mean, to not have a QWERTY keyboard? Like,
so it types like a typewriter.
oh, okay.
QWERTY is the letters that go across your fingers.
Well, right, the layout. But
Yeah.
So you mean it would still have a keyboard, just wouldn't be the
A,
standard,
B, C, D, E, F, G, H, I, J, K, L, M, N, O, P.
or like Dvorak or one of these other layout. Yeah, I got you.
That, he visualized that you don't need to do that. And I said, almost everybody at some point learns about time. A few don't, but almost everybody does. And QWERTY is not great, but we're not going to change it.
Right.
And that's not something that we can do, and it's got to be QWERTY. And he finally relented and said, okay, we'll make it QWERTY. But basically, what we did is once we got the go-ahead, it was just a matter of full speed ahead. Whatever needs to be done to get it out the door, we're going to do it that way. And Houston was in the process of making the video chip for Milton Bradley. So all we did is said, okay, we'll have a meeting, we'll define how it fits in our requirements. If it meets our requirements, we'll put it in the machine. If it doesn't meet our requirements, we'll build our own.
But I guess that's what I mean. When you say your requirements, how did you know how did you get to the point where you knew what a home computer was to you? You know what I mean? It's kind of like if you
we were just imagining what it would be, and so we didn't know. We were flying slightly blind, but we had the goal of, okay, we're going to go and we want a computer, we want it to be in the home, we want it to go to the TV set, we want it to be priced so that eventually it gets down in the hundreds of dollars, not the thousands of dollars. And then we want it to do useful things in the home which aren't being done yet. And then we created, and we had a number of brainstorming sessions about what do we want this machine to do when we get it out, because we want to have software. We know what we want is we want people to develop software coming from everywhere, and that was the press kind of got people on the wrong track, and they didn't pick up the gauntlet, and so we were forced to develop way more software than we planned to do. We just, because the machine had to have software.
Yeah.
And if you didn't entice brilliant software developers to jump on board because they thought that we'd locked them out, instead of locking them in, we were giving them the tools so that they could make a fortune on software and protecting that software. At that time, people didn't know how to protect software. So software was not a commodity. I claim that the person that made software a commodity was Bill Gates. He did not just develop a disk operating system and sell it to IBM.
Right.
He said, you have to pay for every version of it. I mean, you want one goes with one machine. You got another machine, you'll have to pay for that one.
Right.
And before that, you bought one set of software and use it anywhere you want to.
Right.
And he totally changed. I mean, the software was not a real fundamental business. I mean, it was a business that makes big money on a product. Software was a business that pays you to develop it.
Right.
And once you developed it, then it was off and gone,
More
launched.
of a service than a product in its own right.
Right.
Yeah.
And so he completely changed the software business, and it's never been the same since then. It's been, which is not bad. It's a whole industry that operates on a different approach, and where it needed protections and stuff, now it's got really easy. You can download software, but you can't take it and put it on somebody else's machine. It won't run.
Right.
You're going to have to pay money to make it run on their machine.
Right.
And so that's all happened. But we thought, as I say, we might use the thing, but it just wouldn't run fast enough, particularly on the 9900.
But what wouldn't run fast?
The Bill Gates software, it's just too slow.
With the basic, you mean?
The basic, yeah. We needed basic, and it was just way too slow. It's just that our software guy went out and talked to him for quite a while, and came back and said, no, we just have to, so we wrote our own basic.
Right. Well, interestingly, I mean, software is one of the biggest criticisms of the TI home computers. It's, I guess, renowned in our world that, TI was not as either friendly or as open with third-party developers than some other companies were at the time. And some of that, I mean, it seems like you're kind of alluding to some of that, for instance, I've been told there was a chip called the GROM, I guess, which was a component that, kind of served as a lockout in practice, even if it may have not been intended like that originally. But there were some technological implements in the machine that kind of made it difficult as a third-party developer.
Well, the thing is, the GROM, if you wanted your own GROM, all you needed to pay is $1,000.
Well, right, for the mask, right.
That's all it took. Yeah. And nobody ever finally, the press painted it like black as tar. And once they tarred it, everybody assumed that, we expected to have 1,000 people writing software for the machine. Because, if it takes 2 GROMs, so it's $2,000. It's so modest.
Right.
You could have a 5 GROM system and you're only paying $5,000 for, and the software is totally protected. There's no, it can't be compromised, and you can sell these things, these modules, as modules. Is with the hardware level of pricing. And the chips were relatively inexpensive anyway, right, because it was a PMOS design, and we just crank them out like popcorn.
Right.
And so that was the concept, and it got totally twisted around, and we never, the thing is, if you're a kind of private type of company, you don't have the interface to the press that some companies do. TI kind of keeps what they're doing to themselves. from the whole management chain is pretty much that way, because they have a lot of great trade secret type stuff, and it was just a different method. If we'd had people that knew the major magazine editors and dealt with them on a regular basis and advertised that way, which TI didn't. TI had a product, and you look at the product, and if it's a good product, you buy it. You know, you got a catalog of stuff, and you find out who sent the catalogs to, rather than it being someone where you are working with press type of people that can give you can get your information of the right image out, or the image that you would like to see out there. It might even not even be right. You know, a lot of companies are able to influence the press to an incorrect image that they are trying to portray, and convince the press that this image is the way it ought to be, and it may not be the right one. And because of that type of stuff that a lot of companies do, TI just stayed away from that totally. And so we were not, that was probably one of the weakest points of TI as a business, is that they didn't interface actively with that community. Right. And now we had a product where you really needed that kind of help.
Right. Well, yeah, and that's the reason I asked, because, like, for example, if you look at the Betamax versus VHS war, right? I mean,
oh yeah.
The idea being that even though on a technical level, Beta was probably the superior product, but ultimately VHS won because they were much more liberal in their licensing and their willingness to work with.
That's right,
parties.
exactly.
And so that's one of the things that was interesting about what I've learned about the TI machines is, you know, yeah, they had quirks and limitations just like every competitive machine back then, but everyone says that the reason why there wasn't as much a broad ecosystem of software was because they didn't play well with the third-party software people. And I don't mean necessarily on the ground level, but just companies like Apple and Commodore had entire departments that were third-party independent software liaisons. You know, they would
right. Yeah, exactly.
They'd give people architectural documents. They would let them see, you know, the jump table and the kernels. I mean, it's they very much encouraged the third parties to come in and
right.
develop. And it seemed like TI didn't have that.
Yeah, well, that's true, absolutely, because we had a very lean team. I mean, we had a small handful of people. You know, and maybe, I'm not even sure we had 20 people altogether. Sure. Through the whole thing. And they developed, you know, like 10 different products. You know, like the Speak and Spell was a one-man show, one person, one engineer, total work, total all the way end to end, hardware, the whole thing. So we had a really lean team. We didn't have any excess to exercise, and TI normally didn't have that type. When TI wasn't the type of company that did that type of thing, we couldn't go to another part of TI and pull in expertise to interface, and so it was, because TI was not a in general consumer products company. They got into the calculators because the calculator was such a good tool that it sold itself. All you had to do is to figure out how to get it to the channel, and then people bought it.
Well, and it also played into TI's strategic vision of itself as wanting to be seen as a real scientific, you know, engineering company. Right. So yeah, you get a TI calculator in an engineer's desk. I mean, that just gives you the bona fides to say, look, TI is a real legitimate engineering company.
That's right.
To be taken seriously, yeah.
And that makes, it's a difference in the thing. That's one of the reasons why we had the liaisons with some of the other companies, with Milton Bradley, with the control data systems, with the power company that we were dealing with. I forget, is there another? But we worked, we'd go to the consumer conferences and meet with some of the big major players and let them work that aspect of things. That was not part of our job. If we get a good product out there, then they can take that product and the intention was, we don't develop any more software than is absolutely necessary to make the machine play.
Right.
And eventually, particularly once they didn't get the right idea on the GROM, we ended up having to develop a lot more software than we ever intended to.
Right.
From the beginning, I don't think Lynn had in mind that we would ever develop a game,
Right.
that all the games would be developed by somebody else.
Right.
But you got to fire that group up, and the press just closed that gate. They gave us really, just cut us off at the feet. And from then on, nobody understood what we were trying to do, and where that was somebody else's ball. We had no intention to be a major software developer at all. So we hadn't hired, we weren't busy out hiring that kind of people.
Right.
I'm not, some of the people that developed games was just an innate thing that we didn't know that they were good at doing, but they were.
And you're saying these were people internal to TI?
People, engineers. There were some engineers, a lot of engineers like to play games and are good at it.
Of course.
And so that's a byproduct that they weren't hired for that skill. Right. Nobody knew they had that skill until they had a tool that they couldn't resist using.
Sure.
And so that then flowed out. Now I had one software guy that he wrote, a disk operating system normally takes a team of people a year to develop. That's the reason that TI bought Bill Gates. And Bill Gates was able to deliver because he knew a company had written a software system for the North Star computer in San Francisco. And he could go and buy that for $50,000 and deliver it to IBM, but not sell it to them.
Right.
Deliver it to IBM and sell them the rights to use it on a per machine basis.
Right.
And so, of course, that completely changed the way the software business was. But So we took, a calculator has to have some control system that just has software in it. We were used to, we had engineers that were used to packing all the functions that a calculator does in 1,000 words. You go and look, and what they would do is sometimes if you had a 4-instruction set of code doing one function and another function that you needed to do needed that same section, then you would have you'd move it over to a common set and port it over.
Jump table.
And compress the whole thing. So you started with, 2,000, maybe 2,500 words, and you compressed it. And you got it down to 1,000 and still had all the functions.
Right.
And so that was what the calculator people were used to doing. But in terms of, having somebody that really needed to write application software, the vision was, we don't need to do any of that. People write application software all over the place, and once they have the machine and know how to write it, we'll have 1,000 people writing software for us.
Right.
So why do we need to even hire them?
Right.
So we didn't hire any software game type people at all.
Right.
Didn't hire a single one. But I had this one guy, he wrote a full disk operating system when we came out with the 8 and needed to have a disk operating system for it in less than a month, all by himself. And basically had 0 errors in it. He sat there working day and night with his computer there. He didn't draw any flow charts, he didn't do anything. He just sat there at his computer and just typed the stuff in. And a month later he had a fully working operating system with 0 errors.
That disk operating system was shipped with the 994s, or?
It was shipped with an 8.
Oh.
And the disk we had, we had the Shugart disk.
Yeah.
And so we needed a disk operating system with Shugart disk. This was, the 8 was not a home computer. It was strictly a functional computer, a small business computer.
Well, I thought it was never released, though.
The 8?
Yeah.
Well, basically, you take the table with the big box modules and all the modules that plug into it, and that computer, I'm not sure what they were calling that whole system.
The PEB, right? The peripheral expansion box.
The full expansion box without the daisy chain.
Right.
The cable goes up to the expansion box, and the expansion box has all the cards that plug into it. And it had also a Shugart disk.
Right.
4 megabyte hard disk went from 4 to 8. I forget what it was. 5. I think it's 5 megabyte disk. It's a hard disk. Well, you had to have a disk operating system to run a Shugart disk. Everybody that did one, and most of them spent a year with at least 3 software programmers to write the disk operating system.
So you're saying the 8 was actually like if you took the PEB and put a CPU card in it kind of system, or?
I didn't have anything to do with it.
Oh, okay.
It was going on in the background. I was off fixing the optical system for Haggerty, or planning the new display for the home computer, looking at what kind of, I have a design and patent on a whole new CPU that's based on the Forth language. Are you familiar with Forth?
Yeah.
And so it ran the equivalent of running Forth native code.
Okay.
And so it had multiple pipelines that allowed you to run. Forth was a language that came out of San Diego, UC San Diego, and was picked up by the let's see, the hardware company. They made computers. In fact, their offices finally closed here in Austin. But they took that and developed a modified Forth that came out of there that they used. And the nice thing about it is anybody could build a peripheral computer, and all you had is a language, an internal language, and that was written in this Forth version, and it would import. So when you plugged a software into their machine, it would bring in a chunk of software which had the instructions in it to run their machine. So they had pseudo instructions and all you had to do is to write the software for the pseudo instructions, and so anybody that wanted to build peripherals could make it for their machine. Sun Microsystems.
Oh, Sun. Okay.
That's what I was trying to think of. And they did pretty well for a while. It's just, it's cutthroat business that you have to keep your momentum going, and you have to have some alternative products, because the product that you were really counting on got aced by somebody, and starts downhill, and you got to have something else. And Sun had a good product, but they didn't have a second horse to take them to the finish line. But the concept they had for the way they used Forth was which came out of San Diego, was a really good scheme. Anyway, it was a fast-moving time, because if you didn't move fast, you didn't get there.
Sure. Wait, what was your exact job title in the team there?
I didn't really care, and what Lynn did is he would give a person any title he wanted. If you want to call what you've got a branch and be the branch manager, fine. You want to be a branch manager? Okay, fine. You want to be the project engineer? Fine, you're a project engineer. I was the floating architect.
Okay.
And so I didn't have because I didn't care what the title was. I was more interested in doing jobs, doing what was needed to be done. And so if I needed, I didn't have him call me the chief architect or anything. I just took the team and put the information in that I needed, or got permission from Lynn to do things that needed his permission, and trucked on.
But I mean, were you kind of the day-to-day manager of the project, and Lynn was more the liaison to the corporate, or?
I did not do any management.
Oh, okay. Gotcha.
Actually, I'll take that back. Occasionally, I had a person assigned to me that I like building the. I had one engineer that was assigned to me to do the simulator. If I had someone that that person and I were the only ones that were involved, then I would manage him. But otherwise, I was relieved of any management responsibility.
So it was more of a flat team in that,
I was just the technical person that tell me what to do, and I'd go do it.
Sure. Did you use the machines yourself personally? Like, during that time, did you have one of the machines at home that you used as your own? I mean, were you interested in computers for home use?
Not really.
Yeah.
I'm not a really good programmer, and I'm a little dyslexic, so I only wrote software if I absolutely have to. Some of the only software that I wrote was when we got the speech. I insisted on doing the speech module. I said the computer ought to be there, and Lynn said it's going to be too expensive. If you want to have it, we'll just do it as a separate module. But we aren't going to put it in the computer. I really wanted that chip in the computer. But I have to agree, it killed the price. I mean, it pushed the price up to a point, and we were really trying to get the price down. And so if we didn't have the 9900 in there, if we had a 6502 or a new computer in there, nice, fast, low-cost machine, then we could have put it inside, and that would have been okay. But it's not cheap chip, and to get it in there, and it has a little bit of software that's got to go with it. So we did it, and I thought I wanted to get the sound, because I just felt that making the computer talk was really a neat feature that I wanted in the computer. And Lynn agreed, says, well, go get the module built, and we'll put it, and we'll make it available. Mm-hmm. And so I worked with the speech people that did the speak and spell software, the linguist, and one engineer to write some of the software that goes in there. I just don't write software, basically. That's not my forte. I'm a hardware person.
Oh, sure.
And so I had this one software guy, and the same one that did the disk operating system, he spent less than a month, wrote all the software that goes in this module. He was just fantastic. He was Dutch out of the college there and hired into TI Europe, and we brought him over, and he jumped in, and he was a software genius. He could write 10 times as much software as the second best software developer I've seen. He could develop 10 times as much software with fewer errors. And I've read an article, IBM would hunt through their people for some of those. They said, that is a phenomena in software development, that there are a few people that can develop software 10 times faster than the ordinary programmer. And one of the reasons is the flow charts are in their mind. The whole thing, he would sit down, he'd have the computer sitting in his lap, and he'd be sitting here just going and turn out hundreds of lines of code an hour. Just like that. And it almost was errorless. His code just didn't have any errors in it. We wanted software that went with this thing, bam. He came on within a month. It was running in the system, gone.
Do you remember his name?
Herman Schwerman.
Okay. Well, and speaking of software too, one of the games actually that, I didn't know much about the machine when I was growing up. I was more of a Commodore person myself, but one of the really incredible games I knew about the system was Parsec.
Right.
Are you familiar with that?
Yeah.
So, and there's been some interviews I've seen with, I believe it's Paul Urbanus.
Oh yeah.
Where he's talked about some of the technological challenges he had to overcome creating Parsec for the machine. Because again,
right. He did that. He was really good. He didn't even have a bachelor's degree, and he was able to do all that stuff. And when everything went to pieces, he left TI and opened up his own little company, and it was on its rocks, and he was looking for a job. And it was during the period of time that TI had a hiring freeze. They couldn't hire anybody. And he was available in the market. And I wanted him in Dallas in the research lab. I said, he's got the type of talent that he can do wonders. And so I went to the vice president in charge of the research lab, and he said, "Oh, we got a hiring freeze. We can't hire him." And so then I went to his boss, the George Hallmeyer, who later became president of a West Coast company. And he said, "Oh, we got a hiring freeze. You can't hire him." So I went to the executive vice president and told him my dilemma. And he said, "Tell you what, if you guarantee that he will finish his bachelor's degree, you can hire him." He didn't have to finish it to be hired, but if he comes to work for TI, I want you to guarantee that you'll see that he. And so that's what I did.
Right.
And then he ended up working on the display system. When they went back and developed the TV chip into a display system, he worked with that group.
Yeah, because he's one of the ones that he's spoken a lot about what he had to do to make Parsec perform so well as a game. But one of the comments I've seen is that he was one of the people who said the challenge of that was not having documentation or not knowing as much details about the architecture of the system. So that's one of those challenges I alluded to with the independent game developers that,
Right.
some other companies, they would literally just give you a manual, like Atari, for instance. They were also, kept documentation close to the chest. So independent developers would have a heck of a time making games because they said, hey, we would have to...
To your best games, you need some of the internal architecture type of thing. Yeah. No, Paul's a good guy. I knew him well.
What was the first computer that you yourself bought to buy a computer to use yourself?
Let's see, I'm trying to think. At TI, of course, they had computers around for whatever person would want. And when I got into the military systems, I wasn't doing anything that really required computers. I was working at other things. So when I retired and came down to Austin, I then bought what's the name of it? It was a Japanese...
like a Fujitsu or...
Yeah, it was a computer stack like that, and I got that and used it for a while, and then I ended up getting a Hewlett-Packard machine, and I've got 2 Hewlett-Packard computers sitting on my desk over there, and a small Hewlett-Packard back in the bedroom that I use just to demonstrate a current availability of a small machine. But I can use, and the nice thing is I use them for dictation, and it's got I had one, and the guy that's kind of driving the book out of Dallas wanted me to have a good machine to be working on, so he took me over to Best Buy, and we picked a Hewlett-Packard machine with a touch screen and the whole works.
All in one.
It works real nice. The only thing I did is I turned off the pad, because you accidentally drag your thumb on the pad and it does all kinds of terrible things.
Right.
And it's just a nuisance, and I just use the mouse.
Sure.
And so that one works really nice, and it's got voice input and with the software on it and everything. So that's where I'm at now.
Going back to the earliest days of your career, like after you finished school, since you've always worked in technology, obviously computers were probably always around what you were doing professionally. I mean, did you ever envision that computers would be so ingrained into the world we live in today? I mean, if back then, was there a field or an opinion or a view among you and your colleagues back then that, hey, we work in technology, we see where this is going, one day computers are going to be, as ubiquitous as having a blender in the kitchen, or just, the idea that computers would be everywhere?
To some extent, yeah. I envisioned that, you can make them so inexpensive. You can get, as looking at the price, what many computers came out at, $50,000, and then we cut that in half to $25,000, with ours at half the price, and I could see where that could be easily taken down to where you had a $1,000 type of machine in the not too distant future. I'm not sure I fully visualized the level that they've gotten to, particularly like the level of the integrated circuits now. You have what, 100 million transistors on a wafer, on a die.
Billions now.
Yeah, they have a number that have 1 billion on there. And they have, 4 to 6 CPUs. They have coprocessors. It's just, huge amount. And and you still have the supercomputers. You have these great big machines that have I think maybe some of them have 10,000 multiprocessor systems. UT has a big computing center, and I've thought about the possibility that it would, I think I could improve their computing system, but I don't think they want to. Those guys are in the high performance computing engineers tend to be very arrogant, so to speak, and so they don't want any help. Right. And I think I could take their machine and architect a significantly better system, but they're looking at something that's it's $100 million computer. And they have, they now, actually I think the fastest supercomputer just hit a petahertz. There was, you have gigahertz, terahertz, and then the next step up was petahertz. And there's the one supercomputer, just reading one of the magazines, it is now, I think, 1.1 petahertz.
I believe it. Well, the two things that have really kind of boggled my mind are, one, quantum computing.
Yeah.
And what that will mean for our world, and also the idea of optical interlink. I mean, for instance,
yeah, right.
Intel showed off, and I believe it was more than 10 years ago now, but they showed off, instead of using copper traces, the idea that you would directly, optical
connections,
and into the silicon.
And it's, whether that's successful economically or not remains to be seen on terms of yield. One of the things that's always been interesting is that when you need more memory, one possibility is you could stack multiple wafers on top of each other, right? The problem is, if you have a certain yield, and then every time you stack one more, the total yield of the stack goes down, and then they're virtually not repairable when you connect them. So it's never happened that you can get a lot more memory by stacking vertically, and so we've never really gone vertical. The chips have gone a little bit vertical in that I think I was reading that the old chips used to have about 6 layers, and they're now talking about 30 layers in the processing process, that they go through 30 masks to build a chip. And at one time, there were some chips that only required, maybe 4 masks, or 6 was pretty common, and more than 8 was uncommon. And now they, so all that technology, and that's the way they've kept this curve that's been going. And every time someone predicts that it's finally flattened off, it's not going to make it anymore, then they find something, they tweak it, and it goes a little more. Another 2x, and another 2x, and another 2x.
Yeah, I mean, I've seen some interesting packaging they're doing now, where they are actually, the memory chip is a ball grid array on both sides. So, So they have, the memory chip, and then they sit the CPU on top of that.
Right.
And
that gets the communication path shorter. Yeah, I work, the 1 hour that I work for that I go to ARL for is to work with a group on quantum computing. They're looking into various. The biggest problem with quantum computing right now is that all of the serious chips that you have to be kept at almost absolute zero. And so that is a significant expense.
Yeah.
And the other thing is the math isn't quite the same. The big thing that quantum does is it creates the data set that you have that you can pull and get information from, and what you're doing is and instead of a two-dimensional array where you have x-y coordinates and you can go get pieces of information, they have a third dimension, so that you have so that now if you have a 1,000 qubits, then you can search with do 10 searches and find anything on the array, where before you could look at row and you could look at columns, so you had to do 2 searches. Now
Parsing that data.
and so it gives you, so if you go with, people talk about, oh, we're going to have 1,000,000 qubits. Well, there's a fair distance between 100 qubits and 1,000,000 qubits, but and particularly when it's all cryogenically cooled.
Right.
And you got to figure out how to get the data in,
Right.
and how to get the data out. So there are some interesting obstacles to overcome to do serious problems. If you have, there's a few, the haystack search is the one thing that hands down quantum processing does better than anything else. It can go and find that thing that you want,
Right.
and get it to you. And if you've got a big amount of data, like 1 billion bits of information, and you can get that information, 1,000 times faster than any other way.
Right.
But you need a supercooled quantum computer. You need one array that holds 1,000,000 or 1 billion bits, or the size you have, and you need to have a good means to get the information into it and get it out of it. Now, there are certain problems which self-create the information, and you can use quantum approaches to create an array of information. And if that happens to be interesting information, like some of the problems dealing with cryptology,
Right.
then that gets interesting. But it right now is not a universal tool, but is kind of like a coprocessor that you have in your big processing center, these $1 billion processing centers that they're setting up. If you had one quantum computer in there, it may be a really good asset for certain jobs that you want to do. But it's got a long way to go to even get there. And I've seen, we had a guy at TI in Dallas that was working on cryogenic memory elements, and in the research lab. And I'm not sure he totally disappeared. I don't know what happened to him. I think during the Vietnam era, he fled to Canada without a forwarding address. and disappeared from the knowledge of him. It was just like he was wiped out.
Right.
But he used to be there. He was working diligently on cryogenic memory. But the thing is, you get these competing technologies, and one of them gets just far enough down the learning curve so that another technology that might eventually be a much better technology can never catch up, because the learning curve, you know, if you start making millions of the units, the price gets down to where this guy can't compete without pumping huge amounts of money in.
Right.
And then you don't know whether, while you're pumping huge amounts of money to try to catch that guy, he might get even better.
Right.
And you're shooting at
to the future, right?
a moving target.
Right.
So it's hard to predict exactly where some of these new technologies. I can remember in the really early days, people were doing all sorts of things for memory.
Right.
And they were using, you could scan bits of information off of a storage scope.
Mm-hmm. Yeah, heard about that, right?
And other sorts of strange schemes for trying to get a computer system, you know.
Delay line memory and yeah.
Oh yeah. We had bubble memories. TI used to make bubble memories, and the question was making them competitive. The bubble memories looked like they could compete with disks back when a big disk was 1,000,000 words,
Right.
and the bubble memory, you can do 1,000,000 words, and so it could start, you know, and the disks were not cheap,
Right.
and so you could think bubble memories might compete. Now when I don't know what the bigger disks are now, but they're way bigger than a gig.
Oh, terabytes, yeah.
Yeah. And so the bubble memory has, you know, I guess probably 6 orders of magnitude to close the gap.
Right. Well, maybe a better example, I'm sure you've heard of the memristor technology.
Oh yeah.
Yeah, that's probably a better example, which Intel briefly tried to commercialize as, I think, Optane, they called it. But, you know, it was similar, you know, a new revolutionary technology, but when you got NAND flash that's selling for, you know, pennies per gigabyte, how would you ever bring memristor memory to a commercially viable point?
Right, exactly.
Yeah.
It's hard to determine where you might find a dark horse that comes in and then kind of leapfrogs current technology, where you got technology going along and all of a sudden you find something out of the wings is able to leapfrog it and get there. And that happens every once in a while, but it's not.
Right. It's getting rarer these days, I think.
Yeah, but you're going to see it off and on again. It's just, you know, every once in a while there's a technology that has enough behind it, or has somebody believes in it enough to pour that extra bit of money that's needed to give it that shove. But if it hits a sticky spot, then that money, you know, if it needs $10 million to get going good, or $100 million to get going good, and if it still doesn't make it, then you just lost $100 million. Right. But if it made it, it might shove one of these dominant technologies out of the picture.
Right.
And so you can't tell when that might happen or when someone might take it. The example I like to use is instead of electricity being our primary way that we do things in houses, we could have compressed air. And so compressed air comes into the house and it runs little motors.
Yeah.
Anytime you need a little bit of electricity or light, it then spins up a motor
Right.
and gives you the light.
Pneumatic, huh?
And so what you don't have any electric lines going to your house, you just have high pressure pneumatic.
Right.
And of course, in today's environment, it's got so many hurdles to get to that point
Right.
that there's no way. But if in 1860 someone started pushing the pneumatic was available at that time, but in a limited form, but they could have gone that way, and it could have been the primary, most common use for powering what people need for local things.
Right.
But it didn't.
Could have been a very different world today.
Right.
Yeah.
Or if someone had found a quicker way to make a steam engine start, most of us might be driving steam cars.
Well, or also, I mean, look at in the late 1800s and early 1900s, electric cars existed too.
Oh yeah.
I mean, you know, it's funny that now we're coming full circle. To
Yeah,
that.
their range limitation is on them, and well, weight wasn't really a problem in those days, so that was not the big deal. But the battery technology just didn't cut it. If someone had done a little more work on getting a good battery, then that could have completely eliminated the opportunity for having to go through, you know, gasoline has to be refined and everything else, and if all you needed to do is to hook up to get some electricity, but if it goes slowly around town, it's the best you can do.
Right.
And you got to recharge it probably in those days twice a day.
Well, it's funny.
Wasn't going to cut it.
The paradigm, in a lot of ways, I mean, some of the photos I've seen from that era, you know, they would have, you know, a charging plug just like you would tie off a horse back then.
Mm-hmm.
I mean, they have a, you know, 240 volt charging plug, or, you know, it was funny because the paradigm really allowed for that back then. And
Right.
It's funny too that today we're still fighting battery capacity as a limitation of that technology. I mean, in fact, you know, the number one factor people say holding back electric vehicle is range anxiety. The idea that you may be caught somewhere and unable to charge, and you may be stranded on the side of the road. So, I mean, that batteries are still a fundamental hurdle we have to overcome today.
And the location of charging stations,
Yeah.
and where you can get the charge, and how long it takes to charge it, you know, and they're working on different aspects of it, but they've got some fast charging, but there's some problems with using super fast charging.
Right.
But yeah, you got a whole bunch of things that if it's just past the hurdle, and so it doesn't have to miss it by much, you know. If it doubles your cost, you slowly lose out.
Right.
If it's 20% over, you might win.
Yeah.
Because if you have other features that make it worthwhile.
Right.
But cost is really a strong factor.
Oh,